Good morning, guys. It's Naveen joining the call. Can you guys hear me? Could you please type in the chat window? Okay. Thank you, Ganesh. Thank you, Revati. And let's get started, guys. I'm having a little bit of cold, so I'm probably going to be going a little bit slow, but bear with me and just try to keep it at the back of your mind, guys. Okay. So with that, before we start, guys, we started with big data. But ideally, what I would like you guys to do is, I want you guys to continue the practicing of some of the Python sessions that we have done earlier. I want you guys to practice them 1 to 2 times, 2 to 3 times, and kind of get more and more comfortable on a daily basis. Please don't leave it where we left off. We'll be continuing a little bit more. I'll be sprinkling more of Python in the coming up days and things like that. But more importantly, I want you guys to practice all the concepts and techniques that we have learned so far. Practice, practice, practice. If you practice it 2 times or 3 times, that will be very helpful for you in real world when you sit with your colleagues and things like that, guys. Okay, I want you to keep in mind. So again, practice, practice, practice. That is in your hands. We can take the horse to the water, but whether the horse will bring the water is not in my hands. It is in your hands. So I'm trying to motivate you to take you to the water. So having the water, drinking the water is what your practice is, guys. The more the water, the better it is for you, and the better you'll remember, and the more helpful it will be for you. I want you guys to keep in mind. Okay, everybody with me on that? Quick yes, please. Practice a little bit of Python and practice a little bit of the current topics. That's what I want you to do. We have covered inheritance, polymorphism, various classes, objects, and advanced functional concepts. And more of the things are coming, lists, tuples, different kinds of data structures and things like that, and so on, guys. Okay, so please do not forget them because we just started big data. And we're going to revisit all those things in the coming up days, and I don't want you to forget them, guys. Okay, so before we proceed today, let's step back here. And let's say we'll go over a quick review here. I'm going to pause my screen for a moment. Not pause it, but I will actually share the screen. Scroll up here. Okay, just a quick and friendly review. Okay, so one more time, a quick review, guys. The mantra of big data is 3 V's: the volume, the velocity, and the variety. Anytime when people are talking about big data, these are the 3 fundamental V's that they are talking about. Is a mantra that I want you to keep in mind. Okay, if you take any company today, the most successful companies, what is happening? They are generating not the volumes of data, which is 2 times, 10 times, or 100 times, but the volume of data that they are generating is exponential. It is to the power of something else. What used to take 10 to 20 years to generate the data, to get the data into your database, today is happening in a matter of a day or maybe a week. The amount of data that the Twitter, Facebook, they're generating in a day used to take 10 to 20 years earlier. What is this? This is what is called exponential volume. Everybody with me, guys? Quick yes, please. Do any of you remember what is the problem with this exponential volume of data, guys? The hint is on the screen. What is the problem? Okay, the problem is storing is the first problem. The second problem is processing, which is analyzing. If you're not able to process, if you're not able to analyze, you will not be able to look at the results. What is that? Fundamentally, storage and processing is a problem. Okay, so do any of you remember what is the mantra of structured data? Mantra of structured data. It is the reverse of the data. It is the data in the databases is what it is, guys. Okay. Do you need to remember what is the mantra of unstructured data? It is the seas and the oceans, that is unstructured data, that is the semi-structured data. 80 to 90% of the water in the world is in the seas and the oceans. 80 to 90% of the data is in the form of unstructured data. So we're calling that as seas and oceans. They are nothing but free text, images, video, where there is no structure to them. And let's say, do any of you remember what is the difference between batch data? What is the mantra of batch data versus real-time data? Okay, this is like looking at your bank statement at the end of every month. This is like you're swiping a credit card and you're immediately getting a response at that time, which is called the real time. You're collecting the data, you're processing the data at that point of time. Batch data is you wait for a certain period, a delay, and then you process the data. Everybody with me, guys, quick yes, please. Let's see. So slightly high level. What is data architecture, guys? That's a tough question. Data architecture is how do you collect the data? How do you store the data? How do you process the data? How do you integrate the data? How do you analyze the data? How do you make decisions? Is what is data architecture. Cool. Then what is big data architecture? Big data's architecture is nothing but more precisely the same as the previous one. You take big data, you try to store the data. Then you try to analyze the data. Then you try to understand insights. So what are you doing? Data is your water. You go to the water and you try to find the fish in the water. You're analyzing the water. How to find the fish, which is the location where we may find the fish. What is fish? Fish is insights. What do you do? Using the insights, you can make a fish curry, or maybe you can do some other kind of fish curry. Maybe a fish tikka or maybe chicken, fish tikka, or maybe a ginger fish. What is it? You're putting it to use. What do we do? Big data architecture is get the data, analyze the data, and try to understand insights and use them. That's what big data architecture is about, guys. Okay. Then, okay, what do we mean by sources of data, guys? What do you think we mean by sources of data? Okay, if you recall, user-generated data is the data entered by humans. The rest of the data, for the most part, is coming from the machines or the devices. There's two kinds of data. One is human-generated data, another one is machine-generated data. Okay, this is what you enter in your blogs, in your Word documents, textual documents, and things like that. When you use your applications, what's happening? The logs are getting generated. The application, the various kinds of applications are recording what you're doing, what you're accessing, what you're requesting, and things like that. CC cameras are recording your video, audio, and other kinds of things is what it is. So in other words, this is the data that we work with. This is the data today businesses are trying to analyze, understand and analyze, and try to find the insights. Okay, well, where are they getting the data? This is where they're getting the data. Internal data is generally the structured data. This is the reverse. But the rest of it, say, choose this one. The rest of it is what is the seas and oceans. Today, businesses are also looking at it. Until now, or the traditional way of doing the big data or the data analytics is they are only looking at the data in the databases, guys. Okay. So this is where they're trying to get the data. What does it mean by demographic overview versus psychographic overview, guys? Do you remember the mantra? Imagine, I think we were talking about Revati, I think yesterday. She's a woman, she's lady, she's single. She's her age is between 25 to 30. And her income is 80 to 80,000 plus dollars and things like that. In other words, this is traditional data insights. This is small insights. Good, Revati. This is small fish. Okay. Traditionally, what we do, we save the data in the database and we try to look at this and we try to understand. Now, does this tell you that will she be interested in Reebok shoe or Nike shoe? Well, she's making some good salary. So she has some enough money, but I'm not sure if she is interested in Reebok or Nike. So what do you do today? Businesses are going to the web. Notice, she has annual membership in a health club, which means she's into health club means sports clubs and things like that. So that means she's doing a lot of gym and things like that. For gym, probably Reebok is better than her Nike. In other words, it is helping us. She's spending $400 on beauty care products, which means she's also into beauty care. She's into travel, and more importantly, she loves it. She's also into fashion. What is it? This is an example of big fish. This is small fish. Everybody with me, guys. Quick yes, please. And what is it? When you try to understand that kind of things for millions and millions of customers, what's happening? That becomes very, very valuable for businesses, guys. So next, again, internal data. This is generally the data within your organization. This is the structured data. External data. Many times organizations get data from external organizations like credit bureaus to understand if they need to give loans and things like that. That is external data, guys. Okay. What is this an example of, guys? Pregnant men getting pregnant. What is this an example of? This is an example of a horror story, and that is because of the bad quality of the data. It is important that we have having data is important, but more importantly, the quality of the data is more important. Only when the quality of the data is more important, we will be able to get some good and useful insights for the business, is what it is, guys. Okay. So the data quality, what can happen? The quality of the data depends on many factors. Using many other techniques that we are going to see, we will try to learn all these techniques, how to take care of these techniques is what we will learn, guys. Okay. So do any of you remember what does distributed computing mean? It's a tough question. Distributed computing means your data is very big, so you're not able to save it on a single computer. So we're distributing on multiple computers. Once you distribute your data on multiple computers, what is happening is there are many things which are coming into the picture. We need to write code for all these things. We need to take care of all these things manually. What is this? These are the complexities that we are writing code. And writing such complex code becomes super complex. It is not easy. Writing code for that kind of things in every application and things like that. What is that? That is the problem with big data. That's where Hadoop comes in. So what do you think is the mantra of Hadoop, or what is Hadoop, guys? Mantra of Hadoop, how about that? Hadoop is a solution for big data. The technical mantra is it's a framework. What is it doing? It is not only helping us store the data, it is also helping us process the data. It is a solution for distributed storage and distributed processing. Internally, it's like an engine. It is free. It is internally taking care of all the data management with scale out. We will try to understand more about scale out. And it is also taking of distributed storage and processing. Distributed storage is mechanical engineering. Processing is rocket science. It comes in and says, you don't have to be a mechanical engineer to drive a car or a rocket scientist to drive a car. Leave all those things to it, is what it promises, guys. Okay. So what is the next mantra, or what is the other definition of the Hadoop, guys? The hint is on the screen. Processing framework. More precisely, it's a distributed file system. A group of computers, they act like they're a single computer. When we work with Hadoop, whether there are 10, whether they are 100, or whether they're 1,000, it's as if we are working with one computer. Working with one computer is very easy than working with two or maybe hundreds and thousands. The more the computers, the more complexity. That's where Hadoop comes in and says, no, leave that to me. You work as if you're working with one computer. So what is distributed file system? It's a group of computers that act like single computer. Everybody with me? Quick yes, please. What do you think is the advantage of Hadoop, guys, or distributed file system, to be more precise? If one computer can do a certain task in 43 minutes, 10 computers can do it in 4.3 minutes. In other words, there's a ratio in which what we are doing is, if you need more performance, you're not writing the code. You're increasing the servers of the machines and the amount of time is automatically getting reduced. That is the magic of Hadoop. It is linearly bringing down the increasing the performance by reducing the processing time. If you add more servers, your processing power is increasing and your computation time is decreasing. That is what is special. That is what is power of distributed file system. When you work with big data, that becomes very, very big, guys, okay? Because they are working with big data, sometimes some of the jobs may take a day, 7 days, or maybe 1 month. Now you say you add more servers and your performance is, we can do that work in 1 hour, people will go mad. Or in other words, those are the kind of things which are happening. Okay, but how does the distributed file system or Hadoop work, guys? When you give it big data, what is the first step it is doing? Very good. Okay, one more time, let's see. What is the first step it does when you give the data to Hadoop? Splitting. Then what is it doing? It is saving. It first takes the file, splits the file, that is called splits or blocks. Then it is saving the splits onto different computer, that is called distributing. But the problem is the hardware can fail in Hadoop. Why do you think the hardware can fail in the Hadoop world, guys? Okay, because we're using cheap servers, as simple as that. So what do we do? Well, if we save the data on a server and the server fails, what can happen is the data is lost. So what we are doing is we are replicating. That is called making a backup. What is this? This is called protecting the data. This is how Hadoop is protecting the data. Okay, so how does Hadoop work? SDR. It is splitting, it is distributing and replicating. All these things are being done internally by Hadoop. We don't write code. And behind these things, there is much more complex things which are happening. Internode, interprocess, multi-threading, networking, many other complex things are being taken care of and handled by Hadoop. Before Hadoop, the developers were manually writing. What is Hadoop doing? Hadoop is hiding all those things. They say, it's like saying, if you're a cricketer, you don't worry about cleaning the stadium and cleaning the ground. You focus on batting and bowling. Okay, what do developers do? They should focus on the business logic or the analytics logic. They should not worry about the computer science logic. It is abstracting, it is hiding. And it allows us to write scale-free programs, which means if you write a program in Hadoop, that program, if it works successfully on 1 megabytes of data, the program will also work on 100 terabytes of data. No matter how much the size of the data is, it will work. Pardon me. It will work on that, guys. That is what is the magic of Hadoop, or that is what is the good thing about Hadoop. Is everybody with me so far? That is called scale-free programming. Good. So now what is happening here, guys? What is this process called? The first step is, here is a file. And let's say, here is a file. Let's say, how should we put that? The first step is, okay, the first step is splitting. The second step is, this is called saving the file onto a computer. And what is it? That is called distribution. Hadoop calls that as distributing it. Then it is replicating it. Distributed, replicated, distributed, replicated. Okay, so what is that? That is nothing but replicating the data. At a high level, your file is one file, but at a low level, that file is split into multiple splits. Each split is called a block. Everybody with me? Quick yes, please. Good. So now, do any of you remember what is the mantra of data locality, or what is data locality means? Tough question. It is taking the processing to the data. The hint is here. We'll one more time go into the depth of it in a bit. But here, in a traditional architectures, the data is moving and the code is sitting in servers. In the world of big data, Hadoop is making the data sit wherever it is, but the code is moving around. Because the data is sitting, they say data is local, that is called data locality. But why is it important that the data is sitting and the code is moving, guys? Can anyone, if you recall? Why do you think we should move the code around and not the data? Because the size of the data is exponentially huge. The size of the code is very, very small. If you start moving around the data for every single job that we run in Hadoop, it will take up the entire bandwidth and the network will get blocked. So intelligently, they reversed it. They keep the data there and the code is moving around. Again, we'll try to understand that in a little bit more detail, guys, okay? What is the mantra of a rack, or what is a rack, guys? What do you think is rack? It is a group of servers. What do you think is a cluster? It is a group of racks. What do you think is a group of clusters? Where do you think we have a group of clusters? Tough question. Data center. And what do you think is a group of data centers? That is nothing but the cloud computing model. That is what we'll be discussing in Azure and things like that in the coming up weeks, guys, okay? So, what do you think is this switch called? This switch? It is called TOR, T-O-R, top of the rack. It is on the top of this rack switch. What do you think the switch is doing, guys? What do switches do? You connect all the wires to the switch from different servers to the switch. As simple as that. It's a bridge for sending the data. It is just connecting the servers within the same rack or within the multiple racks, and the data flows through the switches, as simple as that. Okay, now there is a subtle difference between the pink and the blue servers. Do any of you recall what is the difference? Here is a hint. How about the blue and the orange here? The pinks are expensive. They are called by any chance, do you remember what they are called? They are called the masters. And the cheaper ones are called the workers or the slaves. What kind of an architecture is Hadoop? What do we say is the kind of an architecture of Hadoop? It is a master worker architecture. Master slave or master worker architecture. Okay. Why do we call the master as a master, guys? And why do we call the worker as a worker? I'll give you a hint. IT company. Because they're like the project managers. What do project managers do? Project managers don't necessarily have to write the code. They don't have to do the work, but they will manage. Okay, and because they are managing, they are called the masters. Everybody with me? Quick yes, please. Okay, and how do they manage? They are maintaining a project plan. What do workers do, guys? What do developers do with project managers? Developers are sending their updates, and project manager is updating his project plan. The project plan is the metadata. The developer is sending, hey, I'm done with task 1. I'm present today. So they keep sending their updates. Now, When we look at name node, job tracker, task tracker, data node, or resource manager, and these things, what are these names, guys? What are they actually? They are background processes. What we are looking at is multiple computers, multiple servers, they're communicating with each other. So this is where multi-node communication, multi-process communication, networking, threading, and all those complex concepts are coming in. What is happening? All this is taken care of by Hadoop. Without Hadoop, developers were manually writing all this. They first have to learn all these concepts, then only they can work with big data. But Hadoop says, hey, don't worry. Leave all those things to me, is what it is. Okay, so in other words, short and sweet, they're all background processes. Everybody with me? Quick yes, please. Okay. Then I think we started trying to understand the pipeline, right? And I think somewhere here we were. So let me just pause the screen here for one moment. Client consoles node, name node, okay. Okay, we're going to go a little bit deep here. Let me just make some changes. Understanding the files. Give me one moment, please. 70. Then we have high. Okay, here we go. So come here. Put this here. Just doing a little bit of cleanup, guys. Just bear with me. Give me one moment here. Sorry about that. Almost done, guys. Okay, I'm gonna save this one. I'm gonna resume this one again. And let's bring this up. Okay, yesterday we started looking at a few commands and things like that. So data node and name node, we have discussed name node is the master or the project manager. Data node is like the worker. What do we mean by data node sends heartbeats, guys? Can do any of you recall what is the meaning of that? Okay, it's like the data node, who's the developer, is sending his project manager an attendance report saying that, hey, I'm present. Every 3 seconds, it sends a TCP signal saying that I'm present, which means the project manager, who's the master, knows that the data node or the server is alive. Every 10th report is a block report. What do you think is a block report, guys? What is a block report? What is the report that the developer sends to a project manager? What is it called? I'll give you a hint. Every weekend, developer sends a report to the project manager. What is it called? It is called a weekly status report. In that week, what are all the tasks you worked on? How much is each task done and things like that is what it is. That is what that one is. Okay. So what is that? Based on that, the project manager is updating the project plan. So what is the meaning of that one? The project plan is the metadata. The master, who's the name node, is updating the metadata, saying that, hey, these are all the servers, the workers who are up, working servers or the slave servers which are up and running. And these are the servers, how much free space they have, how much they have used up, what is the list of blocks they have, what is the list of splits they have, and things like that. Everybody with me, guys? So if you take a look at the metadata here, this is the project plan. So all this metadata is saved to a file. Within the name node, it saves to a file. In data node 1, there are 2 blocks. Data node 2, there are 2 blocks. Here, we're just showing 1 or 2. But in real world, there will be hundreds and thousands of blocks in each server worker. So that is what the name node maintains. Everybody catching it, guys? He's maintaining it. So based on this, he's constantly understanding where there is free space, where there is no free space, and things like that. Which is up, which is down, and things like that. If the project manager, if the master is down, name node is down, HDFS is down. The very important server, the most important server in Hadoop, in the master worker architecture, is the master. If the master is not available, then the metadata is gone. We don't know who's doing what and things like that. So we say HDFS is down. HDFS will be unavailable. We will not be able to get any request from Hadoop. Quick yes, please. Okay. Let's see, let's dig a little bit deep into these things and back to Linux machine. Right here, LTR. The last file we created is data.csv. If you notice, these 3 are the same files. We made the copies yesterday, okay? So I come here. And I think the recent file. Loop commands, okay. Yesterday, these were the commands that we were looking at and things like that. Test, I think I'll comment this one. I need to get back. What do you think is DF, guys? What does DF do? Okay, so let's see, haven't I done? Here is DF. It's in history, it is 203. Pardon me. So notice this, exclamation 203. If I run it, it will execute it. It is giving you disk free space. What does -h tell you? So the same thing, if you run it without H, notice it will give you the same information, how much is used up, how much is freely available and things like that. But notice it's giving you in terms of bytes. -H means, what is it? -H. So when you execute this, -H is getting executed. It's human readable format. So we're able to understand, hey, we have 667 GB still available. So short and sweet, -H is human readable format. Okay. What does DU stand for? Disk usage. What does LSR do? Hadoop FS LSR. Anybody? Let's see if this gives you a hint. It gives you a list of all the files recursively. R for recursive. LSR. R for recursive. LS means just a list of files in that directory. But this is giving every possible directory, the grandchild, the grandchild's great grandchild, every possible directory it is going, and it is giving you a list of all the files. Okay. And let's see, what does Hadoop FS tell you guys? Hadoop FS means that is distributed file system. If you just say LS, you're talking to the Linux file system. If you say Hadoop FS, you're talking to the distributed file system. Everybody with me, guys, quickest please. Okay, what do you think is -RMR? I mean, we should be Hadoop FS RMR. It is removing what? What is this one? It is a directory. It is removing the directory recursively. Even if there are files, anything, it is forcing it to remove. If you just say RM, it will not remove it, is something. What do you think is Hadoop FS move? What's happening when you do a move in a distributed file system?
Changing the data.
What is it, buddy? One more time.
Changing the data, Naveen.
Changing the name of the file.
Yeah.
Renaming it or cutting and pasting it. From where? From first floor to first floor. Not from ground floor to first floor. Move is from first floor to first floor within the file system. Okay. Let's see. What does Hadoop FS CP do? It is copying from where to where? Again, it is copying from first floor to first floor. What do we mean by first floor, guys? HDFS, it is distributed file system. Another shortcut to remember HDFS, guys, is, let's say, here, discard it, put this here. Think of it like this. Imagine we have, let's say, 1, 2, 3, 4, and let's say 5 servers. You can think of HDFS as like a desktop for all these servers. It's a desktop. This is the first floor that we are calling it's a desktop. Okay, imagine we have a file. We have a file in our computer. When we create a shortcut to it in the desktop, what is happening is it looks like the file is here. It looks like the file is here. Imagine we modify this file. Let's say you make any change in this file. What's happening is it looks like this file is getting modified, but really behind the scenes, this file is getting modified. So what is it? When you create shortcut in a desktop, it looks like the file is there in the desktop, but really that is there under your C drive in some folder. What is Hadoop? Hadoop is like a virtual desktop. It is a desktop not only for one computer, it is acting like a desktop for 1, 10, 100,000 or 10,000 computers that you may have. Everybody catching it, guys? That is what we are calling as the first floor. The ground floor apartments are your Linux boxes or the Linux servers. For all of them, there is one desktop, that is HDFS. Behind the scenes, the files are split and distributed in different apartments. But that file, it looks like it is, it looks like it is one file in the desktop. Okay, so let's see. Cool. Okay, can you give me a quick yes, guys? Are you able to digest that? Are you able to understand that part of it? Okay, so back here, copy, we are copying it here from some particular directory. And when you paste it, what is happening is you're pasting it in another directory. You're copying it here, pasting it here. This is fs copy. When you move, right, you're copying this one, cutting this one and pasting it here, which means, let's say you paste it here, you cut this one from this directory, somewhere else you paste it. That is cut and paste. Okay. What is cat, guys? Displaying. It is just displaying. This time, when we say Hadoop fs cat, it is displaying this file from the first floor. Whatever is the data. In the first floor, it is coming and catting it or displaying it. If you just say cat, it is in the ground floor or the Linux server. It is not in the distributed file system. Okay. Then do any of you remember what is put? What will put do? While you're giving a thought, let me just come back here. Just pause this one for one moment. Bring this up. Let's say pause the share. Say. See if I come across. Put copy from local. Not working. See if I have any luck here. Copy from about TP. Linux to HDFS, okay. Put is going from Linux to HDFS, in other words, from ground floor to first floor. That's a good one. Put -L, that's a curl, right? Okay. We're calling it without you especially. Okay. Okay, never mind. Back to resuming it. Okay, so in other words, it's going from ground floor to first floor. It is going from the Linux file system to the distributed file system, copying in the Linux file system and pasting in the distributed file system is what put is doing, guys. Okay. Then let's see. What does touch do, guys? It is creating an empty file, as simple as that. Okay, so let's clear it. Let's go into a few more of them and let's see what we have. Collect Hadoop fs stat. So collect specific information about file or directory. So let's see what that means, guys. Let's say come here and say Hadoop fs stat, and let's see what are some of the files we have from yesterday. Hadoop fs -lsr. The latest one is users.csv. So let's say stat users.csv. Let's see what it gives. Copy this one. Let's say clear it, paste it, run it. Oops. CSV. So it is just giving the timestamp of that directory. It is not giving. But if you look at the definition, it should give us, let's say, the path. Let's give any directory name. Let's see what are the directory names we have. LSR. We have directory called d1_hdp. So let's clear it. Bring up the stat. We'll say d1_hdp. It's giving us the timestamp back here. Let me see, making sure. Hadoop fs stat with the file. Oh, sorry. These are the options that we need to give. %b, %f, %s, and so on. So let's say fs stat. The first one is within double quotes. So put a double quotes here. Say %f. It's a directory. Then we'll also add %b. Bring the previous one. So it is space %b. It's a directory. I think there are no files. 0 means there are no files is what it is. Let us say instead of this one, d1_, let's say dot hash. Let's see what it gives. No trash. Okay. Oh, capital T. Remember, it is case sensitive, guys. So again, it's just giving just the %b. %b is giving the size of the file in bytes. %f will return the F directory. %g is group name. These are mostly admin commands, guys. So that's why I'm taking a little bit time recalling them, because I don't use them that much in real world. Once in a while I use them. So the next one is %g, %n. Okay. Bring this up. Add a %g space %g %n. Let's run it. So it's a big user. One is the name of the group name, and trash is the name of the file name or the directory name. Like that, %r, maybe that is replication factor. That might be something we might be interested in. Yes, %r. Every file is getting replicated, but this is a directory. Let's take, okay, here I think the replication factor will only be 1. And let's see, what is it? Instead of dot trash, let's say users.csv 3. So notice this 3. Behind the scenes, R. This R is nothing but, notice here, R is for replication factor, which means this users.csv has been replicated 3 times. Imagine it is 1 MB. When you put into Hadoop, it will be 3 megabytes. So it has been replicated 3 is what it is, guys. Okay. So let's say copy that one. Copy that one back here. Paste it here. Okay. Control-Shift-C is copying this, just in case. That is the stat command. Next, let's say fs stat, again, the same thing. More options here. You can play around with more of those things. Now, take a look at this, guys. Now, here is something deep. This is a slightly deep one. So notice fs setrep, change replication factor of files within the directory. So for that, what we'll do is, let's see, we'll need a dfs admin, right? Okay. So we just now noticed, we'll paste this one here, users.csv stat. We'll just say %r. And if we run this one, here we go, run this one. Notice it should give us a 3, which means that file is replicated 3 times. Everybody with me, guys? Quick yes, please. Okay, so let's say behind the scenes, what is happening is here is server 1, here is server 2, here is server 3. And back to HDFS. Here's HDFS. This here. Here's HDFS. Now we have a file. Start with this one. This is users.csv. This is users.csv. Now, what is special is behind the scenes, this file is split and distributed. So let us say it is split into this one for the sake of simplicity, into another block. Let's say choose this block, into another block, and choose another one. Choose this one. Let's say give it this one. It was split into 3 blocks. So what is happening behind the scenes? It is splitting, it is distributing. And now something to keep in mind, guys, every block is getting replicated, which means, come here, the yellow block is getting replicated here. Yellow block is getting replicated here. All this is under the ground. All this is being taken care of by Hadoop, but the conceptual understanding we need to have. The green block is getting replicated here, is getting replicated here. And the blue block is getting replicated here, is also getting replicated here. What is this? This is what this replication here. 3 means each block is replicated 3 times. But let's say, come back here. What we'll do is we'll say set rep 4 and we'll give that one. Which means, let's say, Hadoop FS hyphen set rep hyphen set rep, and we'll say 4 users.csv. Okay, let's run it. Replication is now 4. So if you now bring up %r, notice it's now 4. Copy this one, put this here, paste it here. Then what did we %r? So person, so what I did is %set rep 4. And then we verified this one, this was set to 4. In other words, what we can do is, by default, what Hadoop is doing is, here, this is, let us say, some other file. Or in other words, let's say this is user file, but here is another file. Or more precisely, let us say this is users 4. This is some other file, let us say, we have data.csv. Data.csv is replicated 3 times, but there is one file which is slightly more important. It is that file. This one, we want to individually replicate. We want to set the replication factor. This file is very, very important. So we want to say 4 copies of this one in our thing. What can we do? That is what setrep is doing. Where is it? Setrep. Everybody catching it, guys? Quick yes, please. So if you want, you can say.
Go slow, sir. Little bit. We want to execute now.
Pardon me?
We want to type it now, sir. Go slow, please.
I mean, try to paste the syntaxes in chat box.
Are you not able to type it, buddy?
Yes, Naveen, we can, but it's take time.
Acha. Okay. Okay. So we'll start with this one. So copy this one back here, paste it here. These are the 4 important ones we tried today. Okay, guys, you can try one step after another one. Instead of users.csv, you give whatever file name you have. Pardon me. Give me one moment here. Let's move on to the next one. So that is setrep. Everybody okay with setrep, guys? Quick yes, please. I think in this one, this command should not have a stat here. Let me come back here. Let me paste this one more time. The stat should not be here. Should be setrep. No, sorry, I meant to post it in the chat window. Cool. Everybody tried it, guys? Quick yes, please. Okay, yeah, keep trying this. Please do not underestimate it. Please keep trying it. Please work hard. Don't just sit and relax. Okay, count of directories. Oh, yeah. So when you say setrep, what is happening is, by default, what Hadoop is doing is, Hadoop, you give any file, it is making 3 replicas of every block. The blue is there, here, here, here. But for some files, you want more replicas. You want 4 replicas of their blocks. You want 4 times. You want it to be copied 4 times, let us say. Sometimes it could be 2 times only. Or maybe sometimes it's only 1 time only. Then what you do, that's when you say setrep. You say setrep, and it will only copy either 2 times or maybe 4 times or maybe 10 times. Shravi, are you getting it? As simple as that. You can explicitly say some files, copy them more times or copy them less times is what it is. So next, fs count the directories, files, and bytes. Okay, so let's say back to bring up list of files. So these are the list of files. Let's say we have something called demographic data, and it is there in the HDFS. So do we have any data in a directory? Okay, what we'll do, let's say back here, clear, and we'll say Hadoop fs -cp. -cp, it is demographic data.csv. We'll copy this one from demographic data.csv from the current folder to, let's say, room 2. Man, where the hell did it go? Okay. Room 2, let us say /. Try it one more time. LSR, let's see. It's room 2 underscore h. Clear it. Room 2 underscore h. We'll copy this file. Then we'll repeat the same thing. We'll give it a different name. Say demo2.csv. Into the same thing, we're giving it another name. Okay, so let's say, copy them, come back here, paste it for you. It's not copying. Copy this, paste it here. It's Control-C. Okay, so one more time, I'm going to copy it. I'm going to put it in the chat window. Everyone, let's run it. So now what we'll do, we'll go ahead and do an LSR, Hadoop fs-lsr one more time. Back here, we'll verify that. So if you notice, there's a demographic 2 in room_2h demo2, the same file, the same number of bytes, the size and things like that. So we have verified it. Now let's do a clear, bring it up. And what we want to do is we want to do a count. So we'll say back here, say Hadoop fs-count and say room2_h. Copy this, paste it here, run it. Also paste it for you. Okay, so what is it saying? It is saying there is one directory, 2 files. If you add the total size of them, 8,000 and 8,000, roughly coming up to 16,000, this is the name of the directory. That is what count is doing. It's giving you, let's say, count Q and H, get much. It is giving you the directory count, the file count. Directory count means how many directories are there, how many files are there, what is the total size, and what is the path name or the directory name. We can also give -q -h. So in other words, let's say, copy this one, say -q -h, bring this up here. No, sorry. Now say room2_h, infinity. So I think this is giving you more information. -q -h is telling you remaining space quota and remaining quota and things like that. Again, those are more of admin related things. We'll not worry at this time. That is how much space and quota is given for different kinds of people and things like that. But you can keep this one. You probably, this is no overkill at this stage. We don't need the quotas and other things, guys, okay? I'll leave that there for your reference. Everybody with me, guys? Are you trying? Quick yes, please. Okay. So the next one is get merge. Merge all the files in a directory. So now get merge. Concatenate the files into the destination. Okay. So let's see what this means is if you come here. This is a slightly deep one. Imagine a server 1, server 2, and a server 3. Back to HDFS is here. So let's say HDFS is here. Let's say here is our computer. This is our laptop. Now what is going to happen is imagine there are 2 files here. Let's say there's a file 1. Let's say there's a, come here, file 2. Now what get merge does is, oops. Okay, it is going to merge these 2, which means it is going to merge these 2 into one file. Then it is going to take that file, cut it and paste it into your local computer, which means the ground floor. From HDFS, it is pasting it, which is this one, local computer. Here for us, for the sake of simplicity, I'll get rid of this. Oops, not that one. I'll get rid of this one. Our, oops, undo this one. This is our local computer. Our inside our local computer is this one. Oops, put this here. Local inside our local computer. So back, do that. This is our laptop. Inside our laptop, we have a Linux file system. On top of that Linux file system is sitting a HDFS like a desktop. Okay, so when you do merge, it is taking two files, merging it into one. Get merge, the results one. So let me try that one here. So we have result.txt, HDF from -n1, merge all the files. So all the files in the directory. Okay, so let's try that, guys. Come back here. We know we have a demo2.csv and a demographic2 is here. So what we'll do is we'll say, what's happening? Copy this one, paste it here. Say get merge. Get merge, hyphen get merge, demographic data. And what we'll do, we'll not give this one, we'll give the directory, which is room2_h. So what we're giving is, we're giving the directory name. So we'll copy this one. Let's go to Linux, paste it here. And before we do this one, notice this one, we'll say ls-ltr. The latest file, the last file is data.csv. Let's do it clear. And now we'll paste this one, run it. Get merge -nl. I think I need to give get merge -nl. Okay. -nl, run it. Oh, it's happening. Loopfs generic options. So scroll up here. Get merge -l source and oh sorry, I did not give the destination file. So get merge room2_h is our directory. Let's say I want to put it into something called demo2.csv. That is the destination file, and run it. Okay, now if I do ls-ltr, demo2.csv is here. And notice it is 1670. It is 2 times, there is demographic data, 2 times multiplied by that one. And these two, where did it get? It went to the room2 directory, as I explained here. Demo, this is demographic data, this is demo1.csv. It merged these two files in the first floor. Then it copied, whatever is merged into one file, it is cutting it and pasting it into the Linux file system. That Linux file system is inside our laptop here. That's what is get merged. So let's say, scroll down here. Where is this one? ls-ltr, we did this one. Copy this one, put it in the chat window. So paste this one here. Pasting it in the chat window. Okay, before that, what did I do? Before that, I copied these two. I think I already sent these two to you. Oh, sorry. Okay, send them again. Say I copy them. And then you do the get merge. Okay, Stravi, are you getting it? Quick yes, please.
Naveen,
Yeah.
by using get merge, here we are trying to merge the files which are in room2 directory.
Yes, that's right.
Whatever the files are only 2 files.
I think it'll merge all the files. It will, so as the statement says here, notice merges all the files. If you
Okay,
have more
Naveen.
than two, it is putting everything into one file and copying it into your local laptop from first floor to ground floor. Got it, Niharika?
Lavanya, thank you.
Lavanya.
Naveen.
Good. Okay. Everybody else doing okay, guys? Quick yes, please.
Now we want only 2 files means how to merge? I mean, we don't want all files means.
What, buddy? One more time.
Only we want to merge 2 files means.
Okay, you can just go ahead and copy, and there's a merge command in Linux in Linux also, or you just move those 2 files into create another directory, copy them into a new directory, and then do a get merge. Create a new directory, let us say called Rahul. Put your 2 files or 3 files or 10 files into that directory, and then do a get merge. Catching it, buddy?
Okay, Naveen, thank you.
Okay. So back to a little bit of academic diligence. Let's see back here, back to the master, the name node. For the most part, we discussed about this. Well, let's quickly go over one more time, slightly important one. Name node is a master, and it consists of single name node. We generally have only one name node, which is a master server. It is a master. It executes file system namespace. The namespace is nothing but the metadata. Operations such as opening and closing, renaming directories and things like that. So again, short and sweet, it is nothing but the metadata. What is metadata? What are the blocks which are there in different data nodes? It is maintaining a list of them. That is referred as file system namespace. That's the project plan. So going a little bit deep, metadata and memory. One important thing about the name node is it's a very powerful server. What it does is all the metadata it maintains in its RAM. That is nothing but the memory. Why? Because reading the data from the RAM is much faster than reading the data from a file. So it maintains everything in the RAM. So as a result of that, we get greater performance. It is in the RAM. So you don't know demand paging means. This is also a big file. The metadata is a big file. It is not saved to a file system because reading and writing from a file system will take time. That's why they save it to the RAM. It is maintaining what are all the files, what are its blocks, where they are stored, their replication, their permissions, and all that information. That is called namespace or metadata. A transaction log, it also maintains a log internally. Generally, admins are taking care of looking into these log files, trying to understand who added something, who deleted something, and things like that. Everybody okay with this slide? Quick yes, please. So it's like these are the responsibilities of a project manager is what you can think. Okay, now back to the block size. If we have in Hadoop 1.0, the default was 64 megabytes. If you have a 100 MB file, it will split it into 2. If you have a 200, it will split it into 4 of them. The default block size is 64 MB, but you can change it. In 2.0, they have changed it to 128 MB. And if admin wants, they can reduce it to 64 MB. They can also increase it to 256. That is up to them. We don't have to worry about it. So if you have 128 MB, with the 200 MB is getting split into 2 blocks, 300 MB is getting split into 3 blocks. It's just a basic mathematics. It is splitting in the orders of 128 MB, and that is generally determined by it's a configuration which is generally determined by the administrators, not by us. Quick yes, please. So again, for us, how many blocks are there? How did it split? We don't need to worry. We are only worried about the file. We only worry about the file. But it is always a good idea to have an idea about it. So again, the data nodes are the workers. What are the workers doing? I'm still here. This is the 3-second report. They're saying I'm alive. And the name node. So let us say this is my block report, replicate to block 1, 2, 3. So what this means is, imagine here is a file. Let's say here is a file. This file was split into, let us say, block 1 and let's say block 2. So now block 1 was saved on data node 1. Block 2 was saved on. Internally, what is happening is back here, back to block 1 is getting copied here, is getting replicated here. Block 2 is also getting copied here and replicated here. Now let us say for some reason one server went down. Let us say it is this server. Because it's a cheap server, it went down. So notice there is only 2 replicas of block 2. So what will name node tell? Name node will now understand based on its metadata. We have only 2 nodes, and for this block, we have only 2 replicas. So it will send an instruction. It is telling, hey, I want you to get a copy this block, paste it here. So what is it? That is the management. That is the kind of work that the name node is monitoring and managing. If at any point of time one block goes down because the server is down, it is automatically giving instructions to the servers and saying, hey, bring up that block. Everybody catching it, guys? Quick yes, please. Okay, the same thing is what is explained here. I'll not read every word. It's not necessary, guys. We already discussed them. So heartbeat is nothing but every 3 seconds they send a report, a presence report, saying that I'm present, I'm alive. Block report is every 10th report, every 30 seconds report. They send a report and they say list of blocks, list of files, list of other things, of the files and so on. That is what the data nodes do. Okay, then they do not know what is HDFS. Data node does not really worry. What is data node? Data node, remember, is a background process. All it knows is it knows to communicate with the name node. Whether it is HDFS or whether it's some other name, it is not worrying, is what that means. And okay, it does not know whether it is HDFS or what your GFS or what it is. All it is doing is it is storing the block in its local file system. In somewhere inside, there are directories which are configured again at the time of installation by the administrators. It just stores them there. When a data node starts up, it scans through the list of files, understands, sees what are the blocks are there, and sends that report to the name node. So not only every 10 seconds, every 10th report, but at the time of starting up, if it went down and it's starting up again at that time, it will give a first update to the name node saying that, hey, these are the list of files and the blocks that I have. So there it is. Notice out of 4 nodes, one of them is not sending that love symbol. What does that mean? That means this is down. So now what name node will do, it will update its metadata, saying that, hey, one of the server is down. That is what it is. Data node failure. If it is not, if the data node does not send a ping signal, a TCP signal saying that it's alive, then it's updated. If data node fails to send, that means data node is down. Any data that was registered to a data node is no longer available. So now name node will start instructing others. Means it is sending, hey, guys, I want you to copy paste. What is copy paste? IO operations. And the name node constantly keeps track of that. That is what is the responsibility of the name node. Okay, now a little bit of academic importance. What is happening is, imagine we have a file. We have a file. This is our laptop. The file is results.txt. More precisely, we are the client. The client is nothing but here. It is your laptop. Okay. After this, I'll give a quick break, guys. Sorry about that. And what do we have? Well, here is our file. We had a file called results.txt. So now what we did is, you say Hadoop fs put When you say put, what is happening is it is splitting into three. So there is A, there is B, and let's see, find a single C. Here is a C. It is splitting, then it is distributing and replicating. At that time, what is happening is, imagine there is the client is asking the master, the project manager, I need 3 workers. It is not that, let us say for sake of simplicity, here is block A. It's split into, and let's put this here. We'll put our file here. Say this is block B. And let's say here is block C. Okay, what we are trying to tell you is, the client asks the master, which is the project manager, give me 3 workers. The master will get back and say, hey, they are this server 1, server 5, server 8. He will say, it's like saying developer 1, developer 5, developer 8. He will just give a list of names. Now, what is happening is, the client is actually sending the data directly to the servers. It is not that the client gives it to the master and the master gives it. The client directly sends it. That is at the time of writing. That is at the time of writing. So the client is sending the data is one thing. Now let us say we have already distributed. So here is A, B, and C. They are already distributed in. They are there on the Hadoop in the form of racks and things like that. Now what do? We say Hadoop FS get. Get means not get, but we are reading. Reading means you may issue a Hadoop FS cat. When you say cat, what is happening is you give the file name. Again, the similar process is happening. The first request goes to the project manager, says, hey, my file name is results.txt. Can you tell me in which workers the data is? And what is the client master doing? He's just giving back the list of workers. Now, what the client is doing is, client is going to the worker directly and reading the data. It is not that the block A from here is sent to the name node and coming here, but they are reading it directly. This is how the files are read from HDFS. The client is directly reading from here. The client is directly writing to the workers after getting the metadata. What does the master do? Remember, the master is just exchanging the metadata. Everybody with me, guys. Quick yes, please. All these things again, one more time, they're taken care of by Hadoop. We don't worry, we don't have to do anything and things like that. So again, the same process here. Integrity, okay. I can skip this one. This is the same thing, explained in a much more detailed way. But let's take a short break. Let's say 12:35. Let's regroup by maybe 12:45 and continue from here, guys. Everybody okay with that? Cool. Thank you, guys. Okay, sorry about that, guys. Are you guys back? Can you give me a quick yes, please? Rahul, Praharsha, are you back? Great, thank you, guys. So let's say, move the next one. See where we are. Reading files, and let's see, that's where we are. Okay. Secondary name node. Here's another slightly important topic, which is called a secondary name node, guys. So until now, we've been discussing about one of the masters, which is name node. A name node is like a primary project manager. But imagine a secondary name node is like a backup project manager. What does name node maintain? The name node maintains the metadata. Metadata, which has the information about the workers and things like that. What is the purpose of the secondary name node is every few minutes to few hours, it will contact the master worker, which is the manager. It will make a copy of the metadata. Okay, and it will paste it in it. In other words, if at any point of time the main name node goes down, we have a backup of the latest metadata available in the secondary name node, which is like the backup project manager. And what is metadata? What are the list of files? What are the list of blocks? What are the blocks? What is the replication factor? What is the other kinds of the metadata information? All that is nothing but the metadata. So what is that? That is what secondary name node is. He's like the secondary project manager. The only difference is the main name node is the one which is communicating with the entire world, which is the workers and others. Secondary name node never communicates with anyone. He's only periodically communicating with the primary name node and is backing up a copy of the metadata. It is not a hot standby. Hot standby means, imagine here is the primary name node, and let's say here is the secondary name node. If at all the primary name node goes down, what happens is in a few split of a second, this will take up as the primary name node. It will become the primary name node in a split of a second if that is down. What is that? That is called hot standby. You're always kind of on a hot, but this is like a cold standby is what you can think. It is not a hot standby, say, is what it is. It connects to name node every 1 hour. So every 1 hour it is connecting and copying it and pasting the metadata here. It is more like a housekeeping. It is saving the metadata. And generally what admins do is admins can manually copy this, paste it here, and try to bring up the server with the latest changes. And then when the name node is up, again, it will continue to communicate with the rest of the workers and things like that. This is what is one version of secondary name node. Now there's a little bit more explanation to it. So if we go a little bit deep, at a slightly file level, what is happening is here is what is happening. Here's our primary name node. When we say metadata, it is 2 files. Behind the scenes, the metadata is saved in edits file and fs image. These are the names. This is where the metadata is being saved by the name node. Okay, what is it doing? It is always making. This is the copy of the metadata. Any new changes are being made here. And what does it do? It keeps merging both of them into one, and it keeps saving them periodically. That is called a checkpoint file. Every few minutes to few hours, it keeps merging any new changes into the old one, and that is called checkpoint file. Secondary name node, it connects to it every 1 hour. The checkpoint file is being copied and saved here. So at any point of time, what happens is sometimes if the name node goes down, if the primary name node goes down, what we have is a checkpoint file here, which is the fs image. In a particular hour, any new changes which were there in the edits file, okay, these may get lost. What do they do? That's when the administrators will manually try to handle that kind of situations and things like that. There are also automatic process, but for us at a high level, if you have an idea that secondary name node every 1 hour is connecting to this, it is copying the checkpoint file, which is a snapshot of the metadata 1 hour back. That should be good enough. Everybody with me, quick yes, please. Okay, so again, a little bit more at an academic level. FS image is a snapshot of the metadata till 1 hour back. In the current hour, whatever changes are happening are being written into the edits file. The name node is merging these two into a single file, and that becomes a new. It keeps continuing that process. That is what the master is doing behind the scenes. So again, that is called a checkpoint. The same thing I'm explaining in a much more detail. That much is probably, I'll leave that for you to read and things like that, guys, okay? Another slightly important thing to be kept in mind is, so back to our file. Let's say we have a file, and let's say here is file, and let's say it has 3 blocks. Block A is here. Then let's take block B. Then we'll take block C. What is slightly important in this, notice block A is saved in data node 1, 5, and 6. And let's say I choose this one. If you notice block A, it is there, one copy of it is there in rack 1. It's there in rack 1. 2 copies of it are there in another rack. The advantage of this is, for some reason, let us say this rack or this switch goes down, we can still get the backup from here. And the same is vice versa. If at all, this switch or this rack goes down, we're able to get another copy from this one. So in other words, always one copy is saved in one rack, 2 other copies are saved in another rack by default. Sometimes administrators, what they will do is they will configure more. They may want to save the 3rd block in another rack also, sometimes, but that is an overkill. Probably that is not really required for most of the common scenarios. For very specialized scenarios, maybe that is required. So never lose all the data if the entire rack fails. In other words, if A was here, let's say block A was here, and it was here, and it was saved here, and the switch or rack goes down, then we are not able to get the block A completely. Just to avoid that scenario, they're putting 2 blocks in another one. What is happening? This is called rack awareness. By default, Hadoop is handling it. Hadoop is aware of the racks. You tell it, hey, this is rack 1, this is rack 2. The administrators will give a list of IP addresses, and they will tell, and Hadoop is automatically choosing the racks, where to store. The name node is automatically figuring out, okay, if I have to store block A, this data node 1, let me do a little bit of cleanup. Data node 1 is coming from rack 1. Notice data node 5 and 6 are coming from, data node are coming from rack 5. So the master, what is it doing? It is automatically figuring out which data node is in which rack, and it is aware of the racks. That is called rack awareness. Behind the scenes, it's an optimization, just in case we lose the data and things like that. It's an optimization. Keep bulky flows in rack when possible. That also limits the network bandwidth. By following that process, we are not overloading one rack, is what it means, guys. Okay. So everybody with me? So again, notice 1 block in one rack, 2 blocks in another rack, not in the same rack. Repeat the same, repeat the same. For every block, that is referred as replication and rack awareness. Everybody with me, guys? Quick yes, please. So the same thing I'm explaining in words here. The Hadoop client will try to put the first replica on the data node closest to the client. In other words, what it means is closest to client means one rack will go into one rack. The goal of the second replica is availability. If rack awareness is configured, each data node will have rack ID associated. The second replica will be placed on a different rack. The first one in rack 1, the second one in a different rack, and the third one will also go in a different rack. Is to put the block on a separate node to minimize the inter-rack. So again, as a result of that, what is happening is the amount of network traffic is also being optimized, is what it is. If you have more than 3 replicas, then you can choose anywhere. That also can be configured. Again, generally that is handled by the administrators, guys, okay? So change group, this is about changing the permissions and things like that. But let's say move from local. See, this is similar to put command, guys. I will not execute them. This is same as put command, move from local, except that the source local is deleted. So earlier we have seen move. Move is nothing but rename. It's like a cut paste. Where are we cutting? We are cutting in the first floor, pasting in the first floor. Move from local means, notice from local. You're cutting in the ground floor and pasting in the first floor. If we have a file called users.csv in the local, okay, we are cutting it in the ground floor and pasting it. That means you're deleting it from the ground floor and you're putting it into HDFS. That is what is move from local. Everybody understand that, guys? Quick yes, please. It is same as move, but going from ground floor to first floor. Okay, FS usage, okay, shows command syntax along with its options. So in other words, this is like a help. More time, a second here. So put this into chat window. Okay. RM-R shouldn't have been enough. No. So in other words, it's saying, hey, usages, when you use RM, use -f, use -r, and things like that is what it is showing. So let us say instead of hyphen usage, let's say ls. So when you use ls, these are the other options which are used. That's what usage means. It's like a very brief help is what you can think of. Okay, everybody with me? Quick yes, please. Okay, change owners. Okay, will not worry now. But DF again, we have looked at it. DF, there's nothing but disk free space. So let's try. Okay, we'll start with this one. Hadoop FS -df, and let's say, what is our username? Say, I think we had something like disk free space room 2 _h. Let's copy this, putting it in your chat window back here. Oops. Clear it. Room 2h. So now it's giving you how much is size. So what we can do is we can say, oops, one more time. Let's say -h. So it looks like our total size is 1.4 terabytes on this server. Again, disk free, this is disk free on Hadoop, not on local file system. How much it is available? So the total size of the hard drive might be 2 terabytes. The person, the administrator who may have configured the system may have given out only 1.4 terabytes for Hadoop. In that one, this much is available. DF stands for disk free. space is what it is. Catching it, guys, everybody? And -h is nothing but human readable. Quick yes, please. So next one is display the contents of the file. Okay. Like a cat, I think. Let's see. Encoded files. Okay. Back here. Start with this one. -text. Let's say we have something called users.csv. Copy this. Pasting in the chat window. Back to next window. Let's say paste it. Okay. So there's the users. Text is something like a cat. It is displaying. So let's also repeat this with, let's say, demographic data.csv. Try that. See if it displays everything. So it's getting everything. It's like acting like a cat. Takes a source file and outputs the file in the text format. Okay, even zip file. Zip files can also be. It will shows information about the zip files. Next, append to file. Add the content of a text file, local file, to Hadoop. Oh, okay. So let's say part 2 local file and part 2. So let's try to understand this, guys. So I come back here. So back to local file system. This is the Linux file system. Now let's come here. Let's say here is Hadoop. Put Hadoop here. This is the Hadoop layer on top of it. Now notice local file. Here is the local file. What that means is, imagine we have something like this one here. This is local file. Add the content of single text file to Hadoop file. This is in Hadoop. In other words, let's say there is a file here. Now what we want to do is, you want to take this content, you want to append it, you want to add it. Okay, when you append it, actually ideally what is happening is, append means this is on the top, whatever is the content of it is getting added below. So now these two are becoming one file. And let's see, I think what happens is here, it's copying and pasting. It appends means it copies this content and pastes it here. So let's try that. Here. Leave this one. So ls-ltr. Demo 2 is a big one. Let's say cat data.csv. There's our user's information, username, ID, first name and last name, and so on. Let's also say Hadoop fs -ls, press enter. And there's a users.csv. There's a chair1h, that's an empty file. Let's come back. Let's take, okay. So Hadoop fs -cat users.csv. So again, the same thing. In users.csv, this is cool. Let's say I come here, snap it, put this here. Okay, so users.csv, choose this one. This is the Hadoop layer. And where's our local file system? Let's put local file system here. Say, here's the Linux layer, ground floor versus the first floor. Users.csv is on the top, and let's say, we'll say this is users.csv. That is users.csv. Next, what we are doing is we have another one which is exactly the same, but we're calling this as data.csv, which is there somewhere in the ground floor. Next, what we'll try to do, we'll try to append it. So let's say, clear this one, say Hadoop fs -append to file. I think is what it is. So let's say append to file. We first give the local file, which is data.csv is going to be the local file name, and in there it is called users.csv. Okay, so now let's press enter, and then we'll say Hadoop fs -cat users.csv. Notice earlier we just had this content. Okay, now we have added, this is the content coming from the second one. Everybody catching it, guys? Quick yes, please. So copy this one. Paste it here. So copy these two. Send it to you. Try those two things. So this is indirectly, we are modifying a file in the Hadoop. We are also adding the content. We are appending the content at the end. Actually, the direct modification is not allowed in Hadoop Word. So this is like a special scenario where we are appending. Okay. Then append to file. So now local file 1, local file 2, the last file is Hadoop file. Okay. So in other words, you can give as many files. So the same thing, append data.csv. Let's say one more time, we'll say, what is the other one? Let's say users.csv. So these two, except the last file, except this file, more precisely, except, this file, these two files will be taken as the local files. So let's run this one. And now we'll do a cat of users that will be on the Hadoop. So last time we appended, now this is coming from data.csv. Again, we are coming from users.csv. Everybody catching? In other words, we can append from multiple files which are in local folder to a single file. This is like an inverse of a merge. From multiple files, you're taking local file in ground floor, you're putting them into a single file in a first floor. Catching it, guys? Quick yes, please. Okay. That is append to file. Okay. Back to a little bit of theory. So what is this, guys? What is the cluster? If you recall, cluster is nothing but a group of racks. A rack is nothing but a group of servers, right? Hadoop prefers local processing if possible. New servers underutilized for MapReduce. We are yet to get into the world of MapReduce. We are slowly coming there. What it means is, imagine there are 10 servers here. Imagine there are 10 servers here. Today, we had only 10 plus 10, 20 servers. Let's say we had a very big file. Let's say here is a very big data file. And what did we do? Well, Hadoop is splitting it, it is distributing it and replicating it. So all the data got split equally. So what Hadoop does is, it is splitting the data and distributing in all the servers which are available. Okay, but let's say on another day, which is like a tomorrow, you added new servers. Let's say you added 20 new servers. Now notice all the existing data is there in the old servers, but in the new servers, the data is not there. So what will happen is, if somebody is writing some kind of programs, whether that is Hive, Pig, Python, machine learning, deep learning programs, the processing, Hadoop will move the code here. Oops, there you go. Hadoop is going to send the code to different kinds of servers. And what is going to happen? The processing is going to happen. What is the problem here? We have a lot of servers. If you let's say take this one, these are the remaining servers where no processing is happening. Even though we have the servers, the processing is happening more here and this. What is this one? This is called unbalanced cluster. When you add new servers, what we do generally, admins, what they do is they have a few commands where they will say balance. When you say balance, what will happen is some of the blocks will get copied. And what will it do? It will copy in such a way where all the servers will get equal amount of data. So now what will happen is, now the code will also move to these servers. Servers on these racks, servers on these racks. And what is happening is, you have more servers, more work is happening, and equal distribution of not only the data, but also the processing power is happening. It's like if you know, you have 10 people here, 10 people here. So I come here, you have 10 workers here, 10 workers here. These 20 workers are, initially they're working a lot, but these 20 workers are not working at all. That is not a balanced way. So what do? We balance the cluster. Whenever new servers are added, admins again will generally balance the cluster. That is called balancing a cluster. Everybody with me? Quick yes, please. Okay, cluster balancing. So there is a Hadoop balancer. That is one we generally, the admins will run. We don't need to run and things like that. So it will not stop the primary work. If there are any tasks and things like that, it will not stop it. It will run in the background. Periodically, it will check and see. The Hadoop is automatically checking and seeing if there are no tasks being done, then it will slowly copy some of the blocks with the help of the master, and that is called cluster balancing, guys. Okay. So a little bit of going deep into the cluster. Traditionally, what do? The operating system is Linux. We can also use Windows. Last few years, Windows Hadoop can be run on Windows also, guys. In the earlier days, it was only Linux. And Java, it is written in Java. Hadoop was written in Java. So we need at least 1.6 and above. Today, whatever is the latest, that is what we can take. These are different kinds of other utilities, other softwares, other programs. Secure, SSH is secure socket shell. So if you recall, what happens in Hadoop is, there are different computers, there are different servers communicating with each other. There are different processes which are communicating with each other. Okay, what is that? Not only is that complex, but that is not correct. That's a security breach. You cannot have, imagine Gangaram and Pratyusha has 2 laptops. Imagine, for the sake of simplicity, Gangaram is able to access all the files in Pratyusha's laptop. That is not correct. That's a security breach. So in other words, the operating systems are built in such a way, other computers are not able to log into our, or log into our computers and access the resources. Okay, so what is that? That's how they are built into. That's where SSH comes. It stands for secure socket shell. What it does is, if you want somebody else to log in to use the resources in your computer, the files and the directories, what you should do is you should ask them to log in. What is that? That is what SSH will do. SSH is a way where the login, if you give Gangaram's laptop the login details of Pratyusha, from then on, Pratyusha's laptop will accept Gangaram. Okay, that is accomplished by secure socket shell. We'll see that, guys. Okay, cron again is used for running jobs and things like that. We are yet to see that. This is a for rsync is for file copying and pasting from one server to another server and things like that. NTP, I think this is the name, something related to the date and time, to maintain the same date and time of all the servers. What they do is they maintain a single server. And whenever they need the date and time, they don't give their own date and time, but they go to this single server and give the date and time, so that the date and time is consistent with every server. That is what this is, guys. Okay. So again, this is when an administrator, this is the planning your Hadoop cluster is more of an administrator's job. They look into all these details. The popular Hadoop distributions, Apache Hadoop is a free one. Cloudera is the one that we are using. This is generally like our Anaconda. Cloudera, the Azure HD Insights, these are like Anaconda. They have all the common tools automatically installed. HiPig, Scoop, Uzi, all these things are installed in them. In Apache Hadoop, we need to install everything. It's like this is like only Python. but you have to install pandas, you have to install NumPy, you have to install other kinds of packages. Okay, so these are called distributions again. There's Hortonworks. Hortonworks is also a Microsoft distribution that also comes with everything. Mapper is very expensive. Amazon Elastic MapReduce is nothing but Hadoop on the cloud. It's Amazon's version. We also have Hadoop on the cloud on Azure. That is what we'll be discussing in the coming up days, guys. Okay, so a little bit of different kinds of distributions. Everybody okay? Quick yes, please. Okay. So now let's see. Now these are some files which are important from a configuration standpoint. Let's see if they are allowing us access here. Okay, let's see which. I don't know. User bin Hadoop. So that's where break. Oh, okay. Did we? I mean, just give me 10 minutes, Ganesh. Sorry about that. So this is where let us say ls user /bin. Okay, so that's where we have the Hadoop installed, which is a good one. It says cd. These are all the different kinds of binaries which are installed. And say cd cd. Sorry, that's a file there. That's a shell, probably a script in a shell file. So let's come back here. CD will put us back to the same directory. So the configuration files. So where was it, guys? Let's say ls/ on the / temp user wall share opt. I think let's try optional software has been and library cd cd/opt, guys. Okay, this is the root opt. It's ls Anaconda. We have Anaconda here. Then let's say another place where I can serve is cd/ it will be rootlib. Okay, ls. Let's see if we have Hadoop here. There's Java. We have few, but we don't have Hadoop. That's where I'm looking for the configuration files, guys. Different people save it in different places. So let's say cd/user Java, etc. That is also etc Hadoop. Okay, let's try cd/etc/. Let's see, that's the directory. Okay, now notice conf. This is where all the configuration files are generally stored. Hadoop env, HDFS site, Hadoop env, mapred site. These are the files that we are looking at here. Hadoop env, again, these are more from a administration standpoint. Give me 5 more minutes, guys. I'll give you a break. Sorry about that. And let me just give you a quick idea of this one. Environment variables that are used in the scripts and things like that. So if you go into Hadoop env, let's say, this is a shell file. It's if you say cat Hadoop env.sh, there it is. Nothing but it is setting where the Hadoop is. This is telling me, hey, this is where the Java is. And home Hadoop MapReduce. And yarn, we are yet to discuss about yarn. It's nothing but Hadoop 2.0. MapReduce home, where the MapReduce runs, we are yet to talk about that. So that is a shell file. And what is it? It is used for setting some of the environment variables. The most important thing is core site.xml. So let's see if we have that one. Let's say cat core site.xml. This is a big one. So let's see if you scroll down here. say, let's see, Lakshmi, if you're there, can you make me the host, please? Looks like there's been a power cut at mine. Can you make me the host, please, if you're there, Lakshmi? Okay, guys, can you hear me? Oh, there you go. Thank you, Lakshmi. Let me come back here. There you go. Connecting again. Looks like it's to connect again. Okay. This big. This one. So one. It is. Okay. Okay, I think we were in. Quickly. If you type in history, chat window, and that's where we were. We were looking at the core site.xml. I think we were here. So we'll say exclamation 305 notice. Okay, so that's where we were. Then we were looking at cat core hyphen. Sorry, we need to go into conf directory first. cd conf, then say cat core hyphen site.xml. Okay, in here, one of the important things, guys, most important thing is name service one. This is FS default FS. This is the IP address. This can be the server name, or this can also be the IP address of our name node, which is our project manager or the master server. What is this one? That is what core site.xml. The most important setting is this is where Hadoop looks. These configuration files are installed everywhere, wherever Hadoop is installed, and every Hadoop, every server knows where to send its request. It picks up this one. This is the most important setting of the master is what it is. Then there are various other settings we don't need to know. There are tens and tens of settings we don't need to know everything here, but that is core site.xml. So let's say configuration. This is about the IO and the map reduce. So let's say, okay, this is the most important thing. FS default name. This tells you where the name node is. If you go one step ahead, there's HDFS site. This is only related to the HDFS, which is the storage, distributed storage part of it. So let's say back here, cat HDFS site.xml. And again, tens and tens of properties. If you scroll up, we did a cat here. Now, if you scroll down, we are looking for Dfs replication, Dfs permissions, name node dir, data node dir. So let's okay. So guys, it looks like there are some power fluctuations happening at my end. So what we'll do is let's take a break and let's take a lunch break and come back It's 1:35. Today we'll take a break till 2:15, guys, if it's okay. I think we took a slightly longer break earlier. So we'll regroup at 2:15. Everybody okay with that? Quick yes, please. Thank you, guys. Lakshmi, if you're there, can you make me the host, please? Let's see who else is there. Lakshmi is the only host, huh? Lakshmi, are you there? Can you make me the host, please? Okay, great. Okay, guys, let's continue the journey. Come back here. This is one. Okay. Just as part of the discipline, I just go with the history, just to give you a quick recap. We're looking at core site.xml, guys. So I come here. So we were also looking at, so first thing is we need to go into this directory. For that, we'll say exclamation rather than typing it. Just use the shortcut exclamation 314 and cd conf, cd conf directory. Do an ls is a pwd. So we're in etc Hadoop conf, and we look at cat hdfs and site.xml. So notice here, as the name suggests, HDFS means these are all the settings of HDFS, which is nothing but the distributed file system, as the name suggests. So this is where we are indicating how many times an administrator ideally will indicate how many times they want the blocks to be replicated. What are the permissions? Where is, this is where the name node is going to be saving its metadata. And this is the location where the data nodes is going to be saving their blocks internally, is what it is, guys. Okay, so let me see. I have somewhere over masters and slaves, Hadoop PNB. Okay, I guess we don't have. This is the only thing. So notice here, guys, here, right here is the explanation. Let me see. Suresh, can you hear me fine, buddy? Can you give me a quick yes, please? Okay, so DFS replication determines where on the local should store the table namespace image. Okay, I think this should be this one. Actually, this should be pointed here. Replication, as the name suggests, is how many times we want the. This is generally configured by the administrator. And this is where the metadata is configured or saved by the master. Data nodes, for every data node, in which directory somewhere they are saving the blocks. That is what is configured here. Okay, so let's see if we come back here. And let's see if we search for, we have name node service. So it looks like there are two name nodes, a primary and a secondary name node. This is a, oops, oh boy. Okay, so this is where the name service 8020, 8022, these are the IP, these are the addresses. This is like, it looks like it's probably configured on AWS, guys. This is the name node IP, and let's say scroll, here is the DFS replication to 3. This is the setting which is causing all the blocks to be replicated 3 times. Everybody catching it, guys? Quick yes, please. This is a slightly, or this is one of the most important settings. We just need to be familiar. Most of the times, it is at the time of designing a cluster, an administrator will decide based on their budget, based on their data sizes and things like that, guys. Okay, but that is the one. And then DFS block size. This is approximately 128 MB. If an administrator likes to, if more precisely a big data architect is the one who will work with the admin, and they will configure that this can be 64, roughly half of this is 64 megabytes, this is 128. They can also have it 256 or more than that also. And client used data node.hostname. So in other words, this setting, what this is doing, guys, is it is telling, hey, this is, wherever this is true, these configuration files will be there on all the nodes of the cluster, whether you're a master or worker. If this is set to true, that means that particular server will act like a data node. Okay, this is data node.hostname is true. And some of these settings, again, I don't know, enabled. Okay, these are okay. Let's say, scroll down. Metadata enabled is true. So this is not a data node. Here, this is not a data node. The data node is set to false, but metadata is enabled is true, which means this particular server is also acting like a, is acting like a name node. It's not acting like a data node is what it is, guys. That's what this one is. So short and sweet. If we come back here, a few settings is replication is the most important thing that we need to keep in mind. Another couple of important things is these things, name node, name dir, data.dir. These two, name dir is where we are telling the name node or the master server where it needs to save its metadata. That is something I will force you to remember. Data node.dir, behind the scenes, remember, our file is getting split into blocks. Those blocks are nothing but small files internally. Those files, the Linux machines, the ground floor apartments, they're storing somewhere in the local file system. Where do they? That is what this directory is. So this is a directory we are configuring, not we, but the administrator is configuring and telling the Linux file system or Linux that, hey, the blocks, save them in this directory. Everybody catching it, guys? Quick yes, please. Can you give me a quick yes? These are a few settings I will force you to remember. I need you to remember these things, guys. Okay. And okay, the next one is map read site. Let's say if we come back here. Try it another time. There is map read site. Let's say cat it. So this is map reduce. We are yet to talk about map reduce. We're about to get into the story of the map reduce in a little bit and things like that, guys. Okay, so let's say scroll up a little bit. So cat map reduce. This is about the map reduce settings and things like that. Meta info, a lot of things will be there. But let's see. Framework name and okay, yarn site. So let's see. There's a block, compress codec. Map reduce. Okay, ideally, we will need to go back, do a little bit of looking into these settings, guys. But map read. Okay, not. Let me see. This is a slightly older one where we would actually. Sorry, here. Map read framework name. Whether we want to use yarn, we are yet to talk about yarn. We're yet to talk about other kinds of frameworks of map reduce. So. Nothing to remember there, but let's see one more time, LS. Let's see if I have a yarn. Yarn is also here. Cat yarn. Yarn is nothing but Hadoop 2.0, guys. Okay, but let me show you if I can. Okay, here is yarn. Enable to. So this is going to act like your IP address. This is the address of your resource manager or the job tracker, and this is, I think, like a resource admin. This is resource manager dot admin. Then inside that there is an admin, there's a scheduler, there's a resource tracker. These are the other IP addresses. Again, you don't have to by heart them, but I'm just saying you, this is where these are in separate servers. 1204 AP South 1.compute internal. So they're giving different port numbers here. That's all, nothing much, but I'm just showing you. This is just an FYI, guys. Okay, yarn also we generally don't touch. And another one is slaves and masters. So let's say a couple of important things. So if you notice here, slaves and masters, we don't have slaves here. Don't have any directories here. Oops. Okay, so if you notice here, guys, this is a topology map. This is where we are saying rack is default. So here, this is like they're using only one rack here. Generally, in a commercial organization, in a slightly large enterprise and things like that, we will have multiple racks. So this topology map is kind of indicating, hey, there is only one rack. Notice everything is default, but otherwise, this can be rack 1, this can be rack 2, this can be rack 3. Like that, they will give different racks, and HDFS will read this. It will understand which is rack 1, rack 2, rack 3. We discussed about a concept called rack awareness. So at the time of saving the files and things like that, what will happen is these things will get saved there. Okay. So again, these are the IP addresses. These are like the IP addresses. Here they're giving the host names and things like that. Probably these are coming from the AWS service names. That is a topology map. There should be a couple of things I'm looking, especially called masters. But I think maybe in this version, They don't they have not specified it, but let's say space dot dot. There is Hadoop. Okay, let's say find. If you say find, it will give you a list of all the files. And we'll pipe it. We'll say grep for masters. Nothing is there. Let's say grep for HDFS. So there it is. Wherever that HDFS is there, it is highlighting in red. So find means it is finding. It is looking at all the list of files. The output, we're sending the output to grep is search, Control F. We'll talk more about it. This is just I'm just giving a quick touch of it. And no, you don't need to remember these things. I mean, these commands, okay, grep and find, I will ask you to remember. I'll talk more about it. The configuration files is just to give you an idea how the Hadoop is working. A couple of settings and things like that, configuration settings that I said earlier, you remember them manually. In core site.xml, HDFS site, those are the two things I want you to remember. Rest of them is just more of I'm explaining the concept. That's what I want you to keep in mind, guys. Okay. Okay. Ideally, if we come back here, slaves and masters, slaves is nothing but your workers. It is nothing but a file which will contain a list of all the data nodes. Whether you have 10, 100 or 1,000, all the IP addresses will be here. How does a name node know what are all its workers? It looks in the slaves file. Similarly, how do all the slaves know, all the workers know who's their master? They will have a master file in which the IP address of the name node will be there. And that's how they know the master. But it looks like for some reason, those things are not here. But these two, again, I will expect you to remember, Lokesh. How does a data node know where its master is? It looks in the master file. How does a name node know what are all its workers? It looks in the slaves file. Catching it, buddy. That I will force you to remember. Everybody with me? Quick yes, please. The rest of the configuration settings are more of a, I'm just explaining you so that you just have an idea of the concept. This is the Hadoop environment file. Again, these are mostly used by the admins, guys. There are tens and hundreds of such settings. These are all called environment variables. What is the heap size? What is the data node heap size? What is, there are tens and tens of those things. The admins, generally, most of them are left by default, but some of them, they will configure based on their specific scenario and things like that. This is, again, a file which is run at the time of starting or running the Hadoop environment. So earlier, this is, here we are not given the access to directly look at the URL. So ideally, instead of this local host in an enterprise or in a business, you will be given the IP address of the name node, and that is a port number. Similarly, this is the port number of the resource manager. Again, if there are any errors and things like that, for debugging, we go there. Otherwise, we don't really care or worry about them, guys. Okay. So now here is another concept which we need to kind of be familiar. If we notice what is passwordless SSH is, in Hadoop, what is happening is there is a lot of distributed communication. Distributed communication means a lot of computers, a lot of nodes are communicating with each other. So how do these nodes communicate with each other is using this one. A distributed Hadoop cluster setup requires SSH key-based authentication so that the master node can log into slaves to start and stop them without any password. So in other words, what happens is there is only one time. The SSH is secure socket shell. It will ask for any one of the other computers to enter the username and password. Once it accepts the username and the password, behind the scenes, it is making a tag or a record saying that, hey, this has already authenticated. So in other words, let me see if I can explain it like this. Say back here. Let's clean this up. Okay, so here a lot of them are shown as worker nodes, but let's say we'll put one master here. We'll make this as a master node. Rest of them are all workers. So the first time what will happen is when you run a secure socket shell from here into any of the nodes, and it can be run in one shot into multiple nodes. Again, that is not our job. So what will happen the first time, each node, this node, once it accepts the username and password, it becomes its friend. The next time when this node is trying to communicate to this one, if it sees it is already authenticated, then what will it do? It will not accept, it will not ask it to enter the username and the password. That is what is passwordless secure socket shell. You have to, if that is not there every time for every request, whether you want to read, whether you want to write, whether you want to do anything or everything, you need to enter the password. So passwordless SSH is internally that secure shell communication is internally happening, is what that is, guys. Okay, again, just an idea, but move to the next one, a slightly more important one. Remember, HDFS is the brain. On top of HDFS, ideally, we have, let's say, use this one, a MapReduce. Together, HDFS and MapReduce are referred as Hadoop. HDFS is the brain, MapReduce is the heart. HDFS, we call it as a brain because in the brain we store the thoughts. In the heart, what do? We use our heart to analyze the thoughts in the brain. Then what do we have? We have two eyes. Here's one, pig, another one is high. These are the two eyes of Hadoop. What do? These are, just like Python, they are high-level applications which will communicate with the MapReduce. What is MapReduce doing? MapReduce is analyzing. If you want to read, if you want to write, if you want to analyze the data, you need to write MapReduce programs in Hadoop. But the problem with MapReduce is they're complex, they're super complex. You also have to be an expert in Java. That is where Pig and Hive like Python come to the rescue and say, no, you don't have to know all those low-level details. You use simple terms like SQL like language, English like scripting like language is what is Pig. And you give those commands internally, they will generate the Java MapReduce programs. So Hive and Pig are like the eyes. What are they doing? They're exactly doing what MapReduce is doing. They're analyzing the data in a simple and an easy way. That is what is big data analytics. When people are talking about big data analytics, mostly they're revolving around Hive and Pig is what it is. And then the Spark is another big one. Will be Spark and Scala. That's where we'll be talking about Scala in the coming up days, not about Spark, but I'll give you a quick touch of Spark, guys. Then Scoop is, if you want to get the data from any database into HDFS or maybe HDFS into any database, Scoop is a tool. It is a data transfer tool for big data. We can also use Hadoop copy commands. The simple put and get commands we have seen are also nothing but getting the data into HDFS and getting out the data. That is data loading process. Flume is for streaming. Streaming means something like Twitter data or maybe stocks data. Every few seconds, new data is coming in. What do? You take the data from the outside world, use the Flume. Flume is the bridge. It will save the data back into HDFS. These are the top level tools is what we have, guys. Okay, I'm going to get all here. Okay. Okay, that is just again giving an idea. And now, gentlemen, ladies, now this is where the second part of the big data is going to begin. Until now, what we have done is we have focused on the distributed storage part of it. Now, this is where the distributed processing, this is where the rocket science is going to come in. So what we'll do, we'll try to simplify it, guys. Okay, let's try to understand what that means. Okay. Okay, so let's see what's happening. Choose this one. Choose this one. Okay, before MapReduce. What is before MapReduce meaning, guys? Before the world of big data analytics. What was happening? Here's what was happening. Large scale data is nothing but big data. Processing was not difficult, it was super difficult. It was like saying you need to be a rocket scientist to drive a car. Why? You write the code to manage the process, hundreds of thousands. You write the parallelization code, you write the code to distribute the data. You have to write the code for reading and writing the data, how to monitor the status of your tasks running. What happens if your tasks fail? What do? Well, you write code. What is that? All these things were manually being written by the developers or the coders. MapReduce comes, that's where MapReduce comes and says, I will take care of this. If you're a cricketer, you focus on the batting and the bowling. How to build the stadium, how to build the chairs, where to put the chairs, leave it to me. What is that? That is what is a framework. A framework should allow you to focus. If you're driving a car, you should focus on the source, the destination, the brakes, the gear, and the accelerator. You don't worry how the petrol is getting converted to electricity. Okay, so what is it? Car is a framework, car is an engine. That is what MapReduce is. MapReduce is a solution for distributed processing. Hadoop, which is distributed file system or distributed DFS, is a solution for distributed storage. In other words, HDFS is a solution for mechanical engineering, which is distributed storage. MapReduce is a solution for distributed processing, which is rocket science, which is more difficult. Everybody with me, guys? Quick yes, please. Okay, now, if we MapReduce is a software framework. It's an engine for easily writing vast amounts of data. In other words, we are reading, writing, and analyzing data. That could be in terabytes, that could be in megabytes, petabytes, that could be in tens or thousands of computers. You can use cheap servers or expensive servers. And what happens? They can have problems, or in spite of having them, what will that do? It will take care of it. How does it do? We'll try to understand. It is nothing but the godfather of MapReduce is Google. These were the guys who were using this kind of models 30 years back, 3 decades back. Today, businesses are learning them. Why? Because Google became successful using big data. And today, everybody is trying to imitate Google. What was the secret of Google? It is map and reduce. When people talk about MapReduce framework, internally, there are 2 things called map and reduce. That's what we'll try to simplify and understand. MapReduce is highly scalable. Means 10, 100, or 1,000 or 10,000 computers. What do you do? As the size of the data increases, the number of computers increase. What do you do? Don't change code. The same code will work. How is that happening? That is MapReduce. This is the heart of MapReduce. This is what is doing the magic. Many small machines can be used, means cheap machines. You can use expensive or you can use cheap machines. It will still work. And what is special? Programming language. You can write MapReduce program in Java. You can write in Python, Ruby, Perl, C++, and any other programming language also. Everybody okay with this slide, guys? Quick yes, please. Okay, so now let's get into a little bit detail and let's see if we can simplify it more. So before we understand MapReduce, let's try to understand a puzzle here, guys. Okay, here's a puzzle. Imagine here is a library. In this library, let's say there are a few shelves. Let's say this is shelf. Let's say there are some books inside the shelf. Let's say this is book 1, book 2, say book 4, book 3, and so on. Imagine there are book 1,000 books in the shelf. Now visualize there are 1,000 shelves like this in this library. Back here, back here. So let's say here a few books. That's book 2, book 4, book 3, book 1, and so on. And like that. So in other words, what we have is back here. We have one library. There are 1,000 shelves in this library. In each shelf, let's say there are 1,000 books, which means there are close to 1 million books in this library. Now imagine there is, let's say, choose this one manager in this library. And imagine there is one assistant in this library. Okay, so now one day, one customer comes to this library, and let's say he's searching for a book. He goes to the manager of the library and he tells him, hey, I'm looking for a book. Let's say it's Lord of the Rings or maybe Harry Potter. And what does the manager say? The manager tells him, no, I don't have a list of all the books. You need to go to every shelf and search for the book. So what happens, guys? What will happen if a customer needs to go to all these shelves and all search 1 million books to find the Harry Potter or Lord of the Rings? What is the problem? What do you think will be the problem? It takes time. It takes a lot of time, right? So imagine on that day, the customer gives a challenge to the project manager, the library manager, and he tells him he will, by the end of the day, if he is able to give him a list of books, let's say come here, which is like this. Say like this. Let's say book 1, there are 10 books. Book 2, let's say there are 100 books. Book 3, let's say 20 books. Book 3, let's say there are 30, and so on. What is this? This is what the customer wants. You give me a list of the books by the end of the day. What will he do? He promises him he will pay him $1 million. In other words, we have a chance to $1 million. What is the problem? We have one library with 1,000 shelves and 1,000 books. What we need is, we need this kind of an output. Okay, now imagine if one of you happen to be the project manager or the manager of this library, how would you get a list of books like this in one day, guys? Can you give a thought? It's a slightly tough question. What would you do as a manager to get this kind of an output is a question. Any thought? Okay, I'll give you a hint, guys. Let me come here. So imagine an assistant, the manager asks the assistant, hey, go to the shelf, make a list of all the books which are there. If one assistant will go and make a list of these books, okay, what can he do? Well, he will need 1 day to cover 1,000 books or one shelf. In other words, in 1 day, one assistant, okay, needs 1 day to come up with a list of books like this. That is a hint. So now, as a manager, what will you do? What you can do, or what can you do? Anybody guys? What can you do? Good answer. In other words, if one assistant requires 1 day to count a shelf, there are 1,000 shelves here. If we only use one assistant, we will need 1,000 days to count a list of all books. Okay, but imagine we hire 1,000 assistants. Put this guy here. Put this guy here. this guy here, this guy here, put another assistant here. And imagine we hire 1,000 assistants. Let's say this is 1,000 assistant. Okay, what is happening? With 1,000 assistants, we can do it in one day. Good answer. What is happening is, notice as we add more and more resources, our processing power is increasing and our processing time or the computation time is decreasing. What is the mantra? If you add a resource, your processing time, your processing power is increasing. If you want to improve the performance, what you do, you add a resource. Now imagine the manager added 1,000 assistants. Everybody with me so far? Quick yes, please. Okay. And now the manager tells the assistant to follow a certain process. Go to each of the shelf, follow this process, which is, let us say, when you go to a shelf, make a list of, as you come across the books, book 1, 1, book 2, 1. He's asking them to make a list like that. If you come across another book called book 1, then make a note of it like this and continue. So if we come back here, let's say book 1, book 2, and let's say this was book 1. So what is happening? This is how the books are. And now what we are doing is, let's choose this one, choose this one. Each assistant visualizes creating a map of the shelf. Let's say, come here, choose this one, choose this one. This will be on a piece of paper. Visualize. They are making a note of it like this. Book 1, book 4, 1, book 3, 1, and so on. Okay. Everybody understand this step, guys? What the assistants are doing is, each assistant is going to the shelf and they're creating. What is this? They're like how the books are arranged, and this is, they'll call this as a map of the shelf. Can you give me a quick yes? Now, let's say they started at 8 a.m. Let's say by 12 p.m. by lunchtime, they came up with this. These assistants came up with this one. What will they do? The next step is they will go back to their manager and say, hey, we are done with our task. Now, when they are done with the task, let's say come back, let's choose this one. And now imagine what the manager is going to do is, the manager is going to call a college intern. Let's say we have a college intern. He's a very intelligent guy. The manager is going to call the college intern and he's going to tell them, hey buddy, go to every assistant, and here is the piece of paper. What do you do? That is their output. I want you to collect, put it onto a table. So like that, and say the green one, like that, you visualize more and more. He's getting a list of all their outputs. What is he doing? He's transferring the output from the assistant and putting it on his table. Let's say this is his table. On his table, he has put all the, so put that there. He has put all the outputs. Okay, now imagine the college intern is an intelligent guy. He knows that the project manager wants this kind of input. So imagine he wants to help his manager. So imagine he's going to look at each of these pages. How many? There are 1,000 pages from 1,000 assistants. And what is he going to do? Well, let's say choose another one here. Let's say how about this one? Choose, oops, this one. Okay. So now what the assistant is going to do to help his manager is going to make note of it like this. He will say book 1. Let us say book 1 is there in shelf 1 and shelf 2, right? So he's going to make note of it. Book 1, 1, 1. Then come to book 2, let us say, is there in shelf 1. Let's say in 3 shelves out of all 1,000 shelves. He's making a note of it like that. Then come to, let's say, book 4 is also there in 2 shells out of 1000. So let's quickly make a note. Let's say book 3. Book 3 is, let's say, in 4 shelves and so on. He's making a list of all the books which are available. Okay, what is he doing? This is called grouping. The actual output, which is here, looks like this. This output is being transformed into this one. By whom? By the college intern. What is he doing? He's just grouping each book. What are how many group of shells? Everybody understand that? Quick yes, please. Okay, now he looks at his output and says, okay, this is not same as the final output. So what does he do? He looks at his output and he decides to make a small change, which is, if you notice, after book 1, comma 1, book 2 is okay, 1, comma 1, comma 1. Then comes book 4. So what is he doing? He's putting them in a sorted order. Let's say book 3 is there in 4 shells. And continue. Okay, so what is he doing? He has transformed. Here, he's sorting the data. In other words, first thing he has done is he has transferred the data. Transferring the data is where he's getting everything from the assistant. This is the output of the assistant. The output of the assistant he's transferring. Then what he's doing is he's grouping the data. This is where he's grouping the data. After he groups the data, he sorts the data. Now at this point, let's say the college intern stops. He goes back to his manager and tells him, hey buddy, I'm done. Now, what is this one? This is what the manager has, but this is not same as the final output. So now let's say if we have anything else, let's take this guy. So now what the manager does is he takes the help of another assistant, the final assistant. He tells them, hey buddy, the college intern has come up with this output. What I need you to do is take each book. If you notice on the right hand side, what you need to do is you need to add them up. 1 plus 1 is 2. Let's say there were 10 books. What will happen? Book 1 is 10. If book 2 were 20, book 2 will end up being 20. By the time he's done, you have the final output, which is exactly what the customer is requesting. Everybody catching it, guys? Quick yes, please. Okay, so what is happening here is more precisely, the first step where the assistants are coming up with this kind of an output is called the mapping step. Then the second step is where this guy is coming into action, the college intern. The first step is where mapper assistants, we call them as assistants or the mapper assistants, they're creating a map of the shell. Then the second step, say, is where the college intern is coming into the picture. He's doing 3 things. He's transferring, he's grouping and sorting. That is called shuffling, is what we'll call. And the last step is being done by this guy. Choose this one. He's doing the last step. What is this? This is called reducing. Whenever we talk about map reduce, from today onwards, I will be forcing you to remember this puzzle. How we solved a library of 1 million books, where we made $1 million, which had 1,000 shelves, 1,000 books. What was the problem? The manager did not have a soft copy of the books in the library. So what did we do? We did 3 steps here. The first one is map. Let's say do this. The first one is map. And what is the map step? You're creating a map of the shelf. The second step is called shuffle by the college intern. The shuffle is nothing but transferring, grouping, and sorting. The last and the final step is called reducing. What is reducing? Reducing is where you're just summing up. What is map reduce? When I say map reduce, I will force you to remember this puzzle. Everybody with me so far? Quick yes, please. Now imagine, let us say Out of these 1000 assistants, let's say there were only 100 assistants available. If we have 100 assistants available, how many days will it take to complete this job, guys? Instead of 1000 assistants. How many days will it take to complete this job if we had only 100 assistants? It's a simple answer. Give a thought. It will take 10 days. What if you had only 10 assistants? How many days it will take? 100 days, as simple as that. This is called linear scalability. Now, gentlemen, listen to me very carefully. Back here. Okay. What is a shelf? A shelf is like a data node. What are the books? Books are like the blocks. What is block? Block is nothing but the data content. What is an assistant? We are asking the assistant to move to the place where the shelf is. We are not moving the shelf to the place where the assistant is. What is this? The assistant is the code. He's doing the processing. The processing is moving to the place where the data is, that is data locality. Everybody catching it, guys? Quickest place. Okay, if you want to move the shelf to the place where the assistant is, then we are moving a lot of traffic in the library. That is not practical, that is not real. So what do? You move the processing to the place where the data is, that is called data locality. What is data? Data is the books. Books is the blocks. We don't move the data because the size of the data is big. That is what is big data about. Okay, what is happening is all the assistants, if one of the assistants stop working, let us say if this assistant stops working, do you think other assistants have to stop working, guys? If out of 1000 assistants, one assistant has stopped working, do you think others have to stop? No, that is called parallel processing. All the tasks are being performed in parallel. If one of the server goes down, other servers are not affected. This is parallel processing. Okay, and what else is there? That is parallel processing, as simple as that. Okay, what is this? This is a puzzle I will be forcing you to remember in the coming up days. Map reduce means the first step is map. Map is where we are creating a map of the shelf. The second step generally is not spelled out. It's called shuffle. Shuffle is where the college intern is transferring, grouping, and sorting. The mantra is TGS. You transfer, group, and sort. The last step is reduce. Generally, people say map reduce. They don't say the shuffle. Reduce is where you're simply summing and you're getting the final result. This is called map reduce thinking. Everybody with me, quickest please. Now let's get into real world and see how this is. Map, shuffle, and reduce. Very good, Niharika. Keep it up. Now let's come back here. Now take a look at this, guys. Imagine we will now map this into a real world. Imagine a big file, a very big data file. For the sake of simplicity, let us say this file is, let's say 150 MB. Okay, it's not a very big file. So, but we'll start with 150 megabytes. What do? You give it to Hadoop, it will split it into 3 blocks. Let's say it's splitting into 64 blocks, 64 MB. Here is, let's say, another 64 MB. That will be 128 MB. The remaining will be 22 MB. So small. It splits it, then it saves in data node 1, data node 2. Internally, the process of replication is happening, but at this stage, we'll not worry about that. Then what will happen? This is where the assistants are going to come. This is where the code is going to come to each of the data nodes where the data is there. And what will they do? They will start performing in parallel. They're all performing in parallel. What are they doing? This is assistant 1. What is happening? He's coming out and saying book 1, comma 1. What is key 1 comma value 1? Key 1 is book 1. Think of that as. Then let's say this is value 1. Book 7, value 2 is also 1. So what he's doing is he's making a list of keys and values. In the world of MapReduce, we will be thinking everything in terms of keys and values. So what do we say? The mapper assistant has come out with keys and values, is what we say. Then the same thing is being performed by the second assistant and also by the third assistant. Next, what happens? Now this is where the college intern is going to come. Here is book 1 comma 1 and so on. What he's doing is book 2, 1, 1, 1. Book 4, 1 and a 1. Book 6, 1. Book 8, 1 and a 1. What is he doing? He's converting them. He's transferring it. He's grouping it and he's sorting it. Book 2, 4, 6, 8. Book 1, 3, 5, 7. So in other words, he made 2 of them here. But for the sake of simplicity, he's grouping and sorting them. Everybody with me, quick yes, please. So in the world of MapReduce, what we say is the left-hand side is the key. The right-hand side is a list of values. That is a terminology or that is a language. Then comes the reducer. Reducer is the last stage where he's taking each key, he's adding up the values. Let's say these are 3 ones. That will become book 3, comma 3. That is becoming the final output. This is a slide skeleton of the MapReduce of the library that we just discussed. Everybody with me? Quick yes, please. Okay, so now let's go one step deep. This is more for a Java MapReduce programmers and things like that, but slightly for an academic discipline, we'll try to understand what this is saying, guys. Okay. In the world of Java, in the earlier days, when everybody were writing Java MapReduce programs, what they need to do is they need to write a mapper function. A mapper function is nothing but a function. What they need to do is you need to write a function where you're taking the 2 arguments. One is the key, another one is the value. Your key will be, again, you will take a key and a value. You have to write a function which will give you a list of keys and values. Book 1, comma 1. You need to translate that into a group of this one. Okay, these will not vary. This is more from a Java standpoint. So this is at a slightly algorithmic level. We are saying we write a function which will take a key and a value, which will give out a list of keys and values, is what it is. This is again not really necessary for us to understand. That is a mapper function. Then come to a reducer function. Again, back to olden days, not only do we write a mapper function, we also write another function which is a reduce function. What will it do? A reduce is something which will take a key and a group of values. You can use a for loop or whatever you want. What you need to come out to is you sum up all the values, you give me a key and a value at an algorithmic level. It is going to do the grouping, it is going to do the sorting and things like that internally will be happening, is what it is. That is reduce a part of it, guys. That's as much as I need you to know. Don't worry about this slide. These are very, very low level details. You don't need to worry about that. We actually work at a very high level, so don't worry about that. Okay, so now what is MapReduce, guys? We talked about what is called data locality. What is actually data locality? Remember, the assistant, let's say come here. The assistant is the code. Assistant is the code. And what do? You move the code to, the assistant goes to the place where the block of the data is. That is called data locality. It is actually the MapReduce which is moving the data. It is not the distributed file system. It is the MapReduce framework. So Hadoop has 2 frameworks. One is distributed file system. Another one is MapReduce framework. It is a MapReduce framework which is moving the code to the data. It is the one which is asking the assistant to the place where the shelf is. Everybody catching it, guys? That is what is called data locality. It is one of the fundamental design principles of MapReduce framework. And what is happening? The parallel processing is also being handled by the MapReduce framework. Slightly heavy in theory, MapReduce is like that, guys, but stick with me. We'll try to understand how to apply these things in real world in a bit. Everybody with me? Okay, so again, one more time, the same things, more at a slightly at a description level. Co-locating the processing with the data, which means move the processing, ask the assistant to go to where the data is. What will happen? The amount of network that we will use will reduce. You can do more jobs in less time. More processing can be performed, the performance will be very high. What is map phase? Map phase is where, remember for you, this is you can read it later at your own thing, and we'll look at examples in a bit. What is map phase is where our assistants are creating a map of the shelf. Catching the point, guys? Quick yes, please. As simple as that. Then we have the reduce phase. Reduce phase is the last phase. Generally, we talk about the map and the reduce phase because in real world, we don't write the shuffle function. We write two functions, map and reduce. That is what we'll try to understand. Reduce phase is where you're quickly summing up. You take each key, you take all the values and you sum it up. That is what is called reduce. Data is always moved along in the pipeline. So again, data is nothing but the results are always stored in the form of keys and values. Is what it is. So now here is another academic example to simplify that. Imagine a simple file. We have 3 lines in it, deer, bear, and river. For the sake of simplicity, what we'll assume is go back to HD, give this to Hadoop, and we'll say Hadoop is split this into 3 blocks. Let's say the first line in the first block. Here is the second line. Say, move this one, then come here. Here is the third line. Say, put this from here to here. Okay, now imagine it has taken the first block, it has saved on one server. The second block is saved on another server. And the third block is saved on another server. And what is special here? Here we have one line. Now what will happen? This is where the assistant, the code will come to your rescue. Or in other words, this is where the assistant is coming in. There will be one assistant coming here, second assistant coming here, and the third assistant coming here. 3 assistants came, and what are they doing? What they are doing is, you pick up each word. Think of this like a shelf with 3 books. Deer is one book, bear is another book, river is another book. So what you do, you're converting it into a list of keys and value. Book 1, 1, book 2, 1, book 3, 1. Everybody with me so far, guys? Quick yes, please. This is the output of the mapper. Oops. In other words, the mapper assistant is creating a map of the shelf. Shelf 1, shelf 2, shelf 3. Now this is where the college intern comes. That is generally taken care of by the framework. So let's use this. What is happening? He is converting this into bear. Bear, he's looking here in this page, there's another page here. So bear is appearing 2 times, so he's grouping. Bear is book. One is it's appearing in 2 shelves, the first shelf and the third shelf. Repeat that for car here. So what is this? This is grouping. Then notice B, C, DR, he's also sorting now. So he's grouping and sorting. Before that he's transferring. That is TGS, transfer, group and sort. That is called shuffling. Everybody with me? Quick yes, please. So this is the part which is being done by the college intern. Shuffling is happening. Then we have the last step, which is reduce. In the reduce, we are just summing them up. Bear, the book bear is appearing 2 times. And what you do, you put them together. That's a final list of keys and values. What is keys and values? It is the language of MapReduce. You are thinking in terms of keys and values. What are we doing? Which is one line. What is one line here? We're treating it like a shelf. And each word we're treating like a book. So what do you think is the meaning of this final result, guys? When you compare to the input, what do you think of this file? What is this telling you? Does anything? Oh yeah, after this one, I'll give you a break, guys. Sorry about that. What do you think of this one? Okay, why don't you do this, guys? Why don't you take a break? Let's take 3:30. Let's take a break, a 10-minute break here. In this break time, don't answer the question now. It's a simple answer. From this input, I got this output. What is this output is my question. You give a thought. We'll come back from the break and we'll discuss. Fair enough, guys? Okay, let's group in 9 minutes, guys. 3:40. Thank you. See, Suresh or Lavanya, can you make me the host, guys? Suresh, Lavanya, can you make me the host, guys?
Yes, Naveen.
Okay, great. Sorry about that, guys. I was on mute. So, guys, what do you think is output? What does the output look like to you? The hint is on the screen. Okay, more precisely, it is nothing but we are counting the words. The words are like the books. The file is like the library. We're counting the books in the library. It's like counting the words in the file. Everybody understand that, guys? Quick yes, please. Okay, so it's like counting. So more precisely, let's say come back here. Now let's go one step deep and try to understand and apply this in real world. The anatomy of a MapReduce program is nothing but the language of MapReduce, the structure of the MapReduce is nothing but everything is thought in terms of keys and values. The problem with MapReduce is any problem, any program, we are forced to think in terms of map, shuffle, and reduce. We are forced to think in terms of keys and values. It is solving many problems, but it is introducing a new way, new paradigm, new way of thinking, which is in terms of keys and values, in terms of map, shuffle, and reduce. That is what is the complexity that it is introducing. So that is what is keys and values. So now what is blocks? Blocks is nothing but the split of data. And it is called as a physical division. Imagine we have a 100 MB file. If you split it in the orders of 64 MB, it will become two blocks, 64 MB and 36 MB. That is called physical division. What is logical division? Each line inside the file is called a logical division. Each record is called the logical division. Everybody understanding that, guys? Quick yes, please. Okay, then, so again, this is more of a, from a Java standpoint, sometimes in complex scenarios, when we are dealing with semi-structured data such as XML files and JSON files, not every line is treated as a logical division, but a group of lines can also be treated as a logical division. That is what this one is about, guys. But for us, we'll come back to this later. Let's move a little ahead and try to understand how it is, how the MapReduce is applicable in the real world. So imagine the problem. We have a large quantity of documents. Documents is nothing but unstructured data. What is happening today in organizations and businesses is everybody have a lot of documents. and all that is unstructured data. So what can we do? Well, let us see what we can do. If we were to take all the documents and put them as a single file, that would be one big data file. And what is happening? We have lots of lines. So the file is like library. Every line is like a shelf in that library. There can be 100, there can be 1,000, or there can be millions of shelves in that library. What do? We apply map, shuffle, reduce, and output. In other words, take a look at this. A simple file, the quick brown fox, that is the first line. The fox ate the mouse, how now the brown cow. In other words, again, 3 lines here. What's happening? Imagine 1,000,000 lines are there also. Every line is like a shelf. What is happening? One more time, we are coming up with by using the map and the reduce, we are coming up with the words and the counts. Everybody able to understand that, guys? Quick yes, please. Now, this is the mapper at an algorithmic level. What we do, we write a map function and a line function and a reduce function. We come out with a group of keys and values. That is what this one is indicating. So what is happening in map reduce is we're using commodity machines rather than very expensive computers. Big data takes a lot of storage. We have to move the code near the data. The coordinator, we need to have something like a master. That is generally the expensive server. That is the one who is coordinating, who is distributing. And it needs to be reliable. And what can happen is we have to write code for all these things. While you write code, what can happen is your program may fail. Your program may fail at runtime. Your machine may fail, or there might be any other problem. What is it? All those problems are handled by MapReduce. What it is asking you, or what it is asking us, is to write 2 functions, map and reduce. It is solving many other problems, but it is giving us a new complexity. Thinking in terms of map and reduce is what is the problem with it. Okay, so at a slightly high level, these are the different kinds of functions steps which are happening. But now here is a real world log file. In real world, what happens is the log files every 1 hour, they get very, very big. If you get into the world of large enterprises and things like that, in a matter of hours, they're becoming terabytes of files. What do? Well, notice here. In this log file, the first part of it is the IP address. Somebody from this IP address at this date and time, maybe they have accessed our website from this website, google.com. They visited our website. What is this? IP address, date, time, and URL is what we have. What happens generally, these log files end up in terabytes, which is nothing but it doesn't fit on a single computer. They end up in multiple computers. So this is what is big data. Imagine we have log files like this. What we want to do is we want to find URL frequencies. What is URL frequency? Out of each line is one request. Pratyusha, this is Pratyusha's IP. Let us say this is Praharsha's IP. Let's say this is Rahul's IP. Different people are visiting our website from different websites. What we want to do is from which website, from which URL, how many people are coming is what we would like to understand. That is nothing but URL frequency. So what do? You translate that into MapReduce. In other words, here is the first line. This whole thing, IP address, the date and time, and URL is the first line. What is this? Take this as one shelf. This is going to become one shelf for us. This is going to become one shelf. Now what we'll do, each one separated by a space is going to become one word, which is nothing but one book. We're going to treat this as one book. And here is the third book. So in these shelves, we have 3 books. So now what you do, take the first book. Here, what we are interested is, we are not interested in the IP address or the date and time, but we are only interested in the URLs. So what you do here is, it's like saying this is Java, this is .NET, this is maybe data analytics or data science. We're only taking interested in the data science books. So there is the data science book. Okay, it's like imagine Pratyusha is the assistant. We're telling if you come across a Java book or a .NET book, don't count it. But if you come across a data analytics or a data science book, count it. What do? Put a 1. Make note of it. So here's the first one, and book 1, comma 1. This is for the first line of the first shelf. Everybody with me? Quick yes, please. Now imagine this file has millions and millions of such lines. What is happening? You map it. We are mapping. Then what do? We shuffle. At the time of shuffle, what is happening? You're grouping them. Book 1. And you're grouping them all the ones there. Then what do? At the time of reducing, there is book 1. If you sum up all of those things, it's coming to be 1000. Then you have yahoo.com, which is another book, which is coming up to be 5000. In other words, what it means is, if you now look at this result, we can translate this and say, it looks like from CNN.com, we have done an advertisement. We got 1000 requests. And from yahoo.com, we got 5000 requests. In other words, we are getting more traffic from yahoo.com rather than CNN.com. Imagine we are paying a lot of money, or imagine this business or enterprise is paying a lot of money to CNN.com. And what is happening is they're getting very few requests. What do? Well, you stop advertising on CNN.com, save money. Everybody understanding the point, guys? Do more advertising on yahoo.com. Why? Because we're getting more traffic, which means more people are looking at our ad, they're clicking on it. Everybody catching it, guys? Quick yes, please. So what is that? That is the insight. What did we do? We applied MapReduce process to a big data file. Now imagine, instead of the CNN.com, let us say this was a banking website. Let's say this is IP address 1. And let's say this is IP address 2. Okay, now imagine Niharika accessed her bank account, let's say Axis Bank. And what is this? Let us say this is something like not 1000, but this is like 100. Or let's say this is 10 for the sake of simplicity. So she accessed the bank account. She did some transfer. She paid some bills and things like that. On the whole, maybe the total number of requests which went from Niharika's laptop or computer to the bank is 10 requests, which is okay. But let's say here's somebody from Russia, or maybe some very from the hidden parts of China. This is the IP address of somebody which is mapping to hidden parts of China or Russia. What's happening? In a span of a few seconds, our server received 5000. That could be 50,000 or 500,000 requests. What is it? There is a bank, which is Axis Bank, which is more of Indian based, but it has requested in a few seconds 5,000 or maybe 500,000. 500,000 requests from outside, somewhere in the in Russia or China. Do any of you know what is the meaning of that? What does that mean? Why would somebody send so many requests to Axis Bank from somewhere in Russia or China, maybe US, to Axis Bank in a matter of few seconds? Maybe they are hacking. They are overloading our server with too many requests. The ports gets messed up and they try to get into the system. They try to steal. What is it? That's an example of an insight. What is it? How are you getting? By using MapReduce. What are we having? Log files are very, very huge files. You cannot write a Java or a .NET program. What do? You write a MapReduce program. Everybody catching the point, guys? Quickest, please. That is what it is, guys. Like this, we can discuss tens and tens of examples of MapReduce and try to understand in what way it is helpful and things like that, guys. Okay, so that is the story of MapReduce. And now we'll actually try to get into real world, which is high. So let's see. Okay, up to here, some heavy theory and things like that, guys. But this is where we'll go into a little bit of action and things like that. So let me come back here. Say clear this. CD. And let's make sure Hive is here. Bunch of databases already there. Bunch of them already there. Okay, looks like it's already. So let me come back here. Let me find my files here. Looking for Hive. Okay, so one moment, guys. Bring this up. Zoom the share. Okay. So before getting into the world of Hive, we also come back here. There we go. Today, we'll also discuss a few basics of SQL before we get into the world of Hive, guys, okay? And why we'll try to understand when we get into the Hive. So we require a few basics of SQL. Let's see what that means and things like that. So definition, databases are systems that allow users to store and organize data. So we've been talking about Hadoop and HDFS, that is for storing unstructured data and structured data, whereas a database is only for structured data. It stores, we can also organize, we can also analyze the data. They're useful when dealing with large amounts of structured data, to be more precise. Typical users, we can use them in marketing, business, sales, data scientists, software engineers, almost everyone use them. Anyone needing to deal with data can use databases, guys, okay? From spreadsheets to databases. Most users have some familiarity with spreadsheet software such as Excel. In other words, in some way or the other, we are in touch with the Excel and we have been using spreadsheets, guys, okay? So what happens in spreadsheets is, generally spreadsheets are one-time analysis. You quickly need to do something, chart something, you can use a spreadsheet. It is not very, very big in size. The data is not very big in size. So that's when we can use spreadsheet. If it is big, it will have its own problems. Ability for untrained people. These are mostly very, very untechnical people, non-technical people who generally tend to work one time, two times with spreadsheets and so on, guys. Okay. That is where the databases come to picture. Databases provide us data integrity. They can handle massive amounts of data. They quickly combine different data sets. They can automate. They can also support data for websites and applications. This is generally what the web applications are doing. Any application, a web application will generally have a backend, which is generally a database, guys. Okay. So here is an example of spreadsheet. Tabs are nothing but like the tables. In a spreadsheet, if for a moment, if you're taking a spreadsheet with a lot of tabs, then we can think of each tab like a table. These are the columns. Here are the rows. This is pretty straightforward. I'm sure most of you are already familiar with this, guys. Okay. In databases, we have different kinds of databases: Postgres, MySQL, MariaSQL, and SQL Server Express, and so on. Okay. So let me come back here. Come back to the Linux and say, quit this. Let's clear this. And let's say, what am I looking for? MySQL. Access is denied. I see. So one moment. May come back here. May send a message to them. So I'm asking Lakshmi to find out if there's any database server. It looks like there's a MySQL, but it looks like there's some permissions issue there. So let me come back here. Resume it. Okay. So these are the different kinds of databases, guys. Postgres, MySQL, SQL Server Express, Access, SQLite, and things like that. Let's go one step deep. Okay. So Postgres SQL is a great database choice. SQL is one of the databases. Postgres SQL is one of the databases. SQL is a programming language used to communicate with our database. That can be any database. That can be a Postgres, that can be MySQL, Oracle, Access, or SQLite. But SQL is the programming language of the database. Okay, for example, select customer ID, first name, last name from sales, order by first name. Here is an example. Example of an SQL. Select from, order by. These are the keywords. Just like in Python, we have reserved keywords. These are the keywords in SQL. Customer ID, these are the column names. Sales is the tab name or the table name. Again, first name is the column name, guys. Okay. So SQL is useful for a lot of things. So in other words, all these are different kinds of databases. NoSQL databases are for unstructured data. Even they, example, Hive can also use SQL. That is why we are looking at SQL. So here is a DVD rental store. Select is the most common statement used, and it allows us to retrieve information from a table. So select is just to retrieve the information, as simple as that. You're selecting some data is what it is. So imagine select column name from table name. That is the syntax. In a database, we can have a group of tables. And what do? We can select. So let's say table 1, 2, and 3. So come here. Okay. So we have 3 tables. Each table has 3 columns, C1, C2, and C3. And notice they have different values here. So what is database? A group database can be thought of as a group of tables. A table is nothing but a group of rows. It is like our pandas data frame or a data frame. And it is, we can also say it's a group of columns. A group of rows and columns is a table. A table is like a pandas data frame. Everybody with me so far? Quick yes, please. In pandas data frame, if you recall, we say stats dot or a stats column name. Within brackets, we give 1 or 2 columns. We are selecting the columns and things like that. In SQL, we are writing an SQL command. The difference between Python, pandas, data frames, and SQL tables is, in SQL, it is one line. In pandas, everything looks like one word. We're slicing and dicing there. What you're slicing and dicing there, we write it like a line here. That is a subtle difference, guys, okay? So there is select column name from table. So in pandas data frame, you'll say table 1 within brackets C1, if you recall, or table 1.C1. That's like a word, this is like a name. And we need to be familiar with both of them, guys, okay? So select C1 from table 1 is going to select that particular column. What is this? This is the syntax. Select and from. You here we're giving in capitals, but you can give in anything. Okay, next, let's say select C1, C2. That is selecting 2 columns. This is also slicing and dicing, but using SQL is what we are seeing from table 1. Next, select C1 and C3. So it is selecting the column C1 and C3. If we say select star, we're selecting all the rows. Everybody with me, guys? Quick yes, please. Can you give me a quick yes? Do any of you here not have an idea of database, guys? Can you give me a quick yes? Any of you don't know database? We have given the big date should be available within. Please check. Let's say, okay. Looks like SQL access is denied. Getting an access denied. Let's send this one. So copy this one. So error message. So please verify. Okay, I'm just checking with Lakshmi and the support team to see if we have a direct access here. May type in Cloud Labs. Sign in. Say ULab. Okay, in web shell, when I was trying MySQL, I was getting this one. We can use any of the databases, guys, but let's see. Let's get into Hue portal. Let me see this username. Okay, so oops. Sign in. So Hue portal is another one which allows us to, so there is Impala Hive and Solar SQL. We can also, instead of using the console here to type in the commands, we can also use this editor. We can type in all these as Hive commands, but before we go into Hive commands, I want to actually access a table. These are all the tables which are already available, which have been built by various other users, it looks like. This is for Hive and Impala, guys, okay? Let's come back here. This is what I'm getting. Give me one more moment. Okay. Still waiting. Come back here. Say resume this one. Back to Cloud Labs. Let's go to Cloudera Manager portal. Try to use one. save it. So this is the Cloud Error Manager, guys, portal, which generally used by the administrators and things like that. So we're yet to see Hive and all these things, but let's say click on Hive here. Oh no, HDFS here. This is what the administrators are constantly monitoring. Their failover controllers, other kinds of things. Again, we don't need to worry about them. This is giving a quick idea of the performance of the disk time, average disk time, and different analytics about the HDFS servers. And these are the instances. Let's say go here. Okay, looks like we have a bunch of them here. Good health, 22 in good health. Commission state, so let's say go into racks, 23, default, I think maybe. Let's say go back to status here. HDFS summary, configure, help us 9 of them, balances 2 became good, okay. Looks like some things have changed here from last time I looked at it. So that is the name node web UI, click on that. It's not allowing us to access it from outside IP. It's not configured. And let's say back to instances. So data node 1 and so on. HTTPFS, different kinds of services which are running. So here's a standby and an active. This is like the standby is the hot standby. This is the primary, this is the secondary name node, but this is hot standby. In the later ones, they have introduced hot standby. I think that's what we have. So it looks like we have a bunch of data nodes here. And yeah, DFS admin, FS admin, oh sorry, Hadoop, DFS admin is the one. And in this one, this is generally used by the command used by the report. DFS admin, say hyphen report. So access is denied. Super user privilege is required. So roughly here, it is also giving us how much is the space remaining and things like that. Under replicated blocks, over replicated blocks. If something has less blocks, if something has too many blocks, that is what this is giving. It will also give us information, how many data nodes are there and things like that. What is this one? This is Hadoop DFS admin report. Most of the time, these people use it, guys. The admins use it. But give me one moment. Let me see, go back here. Okay, still working on it. All right. Okay, back to select. Let's resume it. Okay. Okay, so what we'll do, select start from. I pause this one. Let's see how many are here. Okay. Let's see if I can simplify this one. Keep this here. DVD rental. There are some columns. Select the statements, grab. Names of it. So here's what we need. First name, last name from customer. Okay, let's try this one, guys. While I have the, say this one. I resume this. Bring this up. Okay. So here is one example. This is a screenshot of a database in pgadmin, DVD rental. There is a database called DVD rental. We'll see how to create a database. We'll see how to create the tables in a bit. In this one, there is a table called actor, in which we have columns called actor ID, first name, and last update. And gentlemen, ladies, before I proceed, can you quickly type in a no, or let's say a yes? Just type in yes if you are already familiar with database. You're not familiar. Bunch of them. Okay. Oh, I guess. Okay, that's okay. I got it, guys. Okay. So now this is just to give you an idea of an editor of pgadmin. But let's say here is a small task. The task is, imagine we have some customers' data. We want to send out a promotional email to our existing customers. So in other words, we'll see how the customer's data is going to look like. And we want to send out a promotional email. We need to send out an email to our existing customers is what it is. What is it? Well, if you look at this, we use a select statement to grab the first and the last names of every customer. In other words, we want the first name and the last name. Here is an example. This is the first name, this is the last name, this is the email, this is what we need to get from our data. Jared Ali, and so on. That is their customer name. So ideally, from a SQL standpoint, what do? We say, back here, snap it. Okay, select first name, last name, and we need first name, last name, and email. Those are the three columns. Select and from are in caps for the sake of discipline. We have put them in caps. You can also give them in small letters in SQL. And what are they? They are nothing but the column names. We are saying select. When you say select, we are selecting, or SQL is selecting is one way to think of it. From customer, what is customer? Customer is a table which is built into it, is what is happening. So what do? Well, if you execute that, you will get your result, which is first name, last name, and email. So here, what I'm trying to do is we're just trying to understand what is called select, as simple as that is. Okay, I'll execute it. I'm just waiting for to see if I have access. Give me one more moment here. Back here, select, and let's say here. So here. Okay. We're on it. Leave there. Post it here. Back here. Okay, looks like Lakshmi is working on that. And so while that is on it, let's come back here. Okay, so here is distinct, guys. While we are waiting on that, let's also see what we have. Sometimes a table contains a column that has duplicate values, and you may find yourself in a situation where you only want to list the unique or the distinct values. The distinct keyword can be used to return only the distinct values in a column. In other words, distinct is unique, as simple as that. Back in pandas data frame, we discussed about unique, that is what is distinct. Instead of saying select column, you say select distinct column. You use distinct. There, you say data frame, stats.unique. Here we say select distinct, that is what is the difference. So select distinct of column, you can also use the brackets. So now if you notice here, imagine a table of people who were surveyed to choose a color. Zach chose green color, David is green, Claire is yellow, David is red. So now what is happening? Select distinct name. What is name and choice? Name and choice are column names. If you say select distinct names, you want unique names, you will get in this David and David is duplicated. Okay. What is the data structure which does not accept duplicates, guys? Do you need to recall? It is a set. So what is distinct? The distinct is doing what is set is doing. It is removing the duplicates. If you say select distinct name, you are only asking the name. I just want the name from this data frame. So indirectly for us, this is like a data frame. Give me only name and only unique names. Everybody catching that, guys? In other words, come back here. So this is our data frame. And we just want name. Let's say I choose, we just want name. In this name, we don't want the duplicates. So imagine for say either this one or this one can be deleted. We should get Zach, David, and Claire. And what's happening? That's what we are getting, Zach, David. So distinct is nothing but unique. Then it takes more sense to ask how many types of unique color choices are there. Means you can also grab unique choices. What do? You say select distinct choice. Green, yellow, and red. So what is distinct? Distinct is unique, as simple as that. Everybody with me? Quick yes, please. Okay. Imagine another one, select star from fill. Star means you want the complete data frame. Everything in the data frame. So there it is. If you say select star from, here we have film ID, title, description, and things like that. So we're getting all the rows and all the columns. Select star from. Now this is a little bit of SQL we need to practice. We need to manually remember what is select star from, what is select column name, column one, and things like that is what we need to remember and practice, guys. We can also say select distinct of release year, which means there are many movies with many years here. If you say distinct of release, we're only getting one, which means in this one, all of them have been, we have a list of movies which have been released in the year 2006 is what it is. So again, one more time, short and sweet, distinct means unique. In that column, it is giving you unique values is what it is. Okay, back to select star from film is getting everything. Select distinct rental rate. One more time, give me unique rental rates. So what is happening? In this table, there are some rentals are $2.99, some are $4.99, some are $0.99. By using star, we can remove the no. Star means everything. It will not remove. Distinct is removing the duplicates. If you use star, you're getting even the duplicates. If you say distinct, that's when you're removing the duplicates. Catching it, Lokesh? Okay, so let's say situation, an Australian visitor isn't familiar with MPA movie ratings, PG, PG-13R, etc. We want to know the types of ratings we have in our database. What ratings do we have available? So let's say here is the result, MPA rating, 17G, parent, guardian, 13, rated, and things like that. So let's see what is happening. Select distinct rating. Again, distinct will give unique from films is what it is, as simple as that. If you want the ratings, you want to know what ratings do we have, what do we do? You can say select distinct. If you don't say distinct, duplicates are coming. If you say distinct, duplicates are gone. Catching it, Lokesh? Okay. Next, let's say select distinct rating from film. And next one is count, okay? The count again, a few of them, I will probably run these things tomorrow, but let me cover a little bit of theory. The count function returns the number of input rows that match a specific condition of a query. Count is nothing but count, guys. If you go back to data frame, it is nothing but the length, it is nothing but the count. As the name suggests, count is count. Okay, so take a look at this. Select count of name. Count of name means you're taking the name column. How many rows are there is what you're asking it. You should get 4. Okay, this is simply returning the number of rows in the table. You can, each column has the same number of rows. Whether you say name or choice, you'll get 4. It includes the duplicates here. Are you catching it, guys? Quick yes, please. You can also say count name, count choice, or you can also say count star. Count star is also counting how many number of rows are there. You can either use a column name or a star. Generally, we will use a column name rather than a star. That is slightly performance optimized, guys, okay? Because of this, count by itself simply returns back a count of the number of rows in the table. Count is much more useful when combined with other commands such as distinct. So take a look at this. Imagine we wanted to know how many unique names are there in the table. How many unique names are there? How many of them are Zach? How many of them are David? How many of them are Claire? What do? Select. First, you do a distinct of name and then you're doing a count. So first you're getting unique names and on top of that, you're getting a count. Okay, so those 2 are duplicates. And now we're getting these 3. So that is 3. In other words, let's say, select count of distinct. Distinct means, okay, it's getting 3. Count of distinct. So when you say distinct of name, this will happen, guys. First, imagine or visualize from the big table, 3 rows are selected. Then you're counting how many rows are there. That is giving you 3. Okay, so let's say, let me see, I'm saying if I can give you a much more simple example. Okay. Okay, I'll see. Count of distinct of name gives you 3. You can also give distinct of name within the brackets or a parenthesis like that. But let's say, take a look at this. Imagine we are looking at a table called payment. And let's say the payment has payment ID, customer ID, staff ID, rental ID, amount and payment date. Now what we are doing is count of star from payment. We're getting 14,596. Let me check something here. Okay, still working. Back here. Okay. Okay, one moment. Go up here. Try to make a little. So where we were here. Bring this up. And let's see, resume the share. Okay, take a look at this, guys. We'll cover a little bit more theory before we get into. So select star from payment. We have different kinds of. So select star from payment means star means the total number of rows. That will give you 14,500 and sorry, select star will give you all the rows and columns. Select count of star is giving you the total number of rows and columns, the length of it, 14,596. Okay, so star and count of star. Then come here. Count of amount below is also same. Whether you do count of star or count of amount, it is the same thing. Next, select amount from payment. Okay, so let's see. What I would like to do is, okay, back here. While the MySQL is getting set up, let me come back here. Let's get back into Hive here. Let's see if I can actually run these things here. Show tables. Let's put semicolon. Let's say there are a bunch of tables already here. Z stock, zone, stock X. Let's say describe that stock EX, put a semicolon. These are the S names, stock name, stock date, high, low volume. Okay. So let's say we'll say select star from Z stock EX. Stock EX. Looks like we have a bunch of stocks going on here. Doesn't look like they're mapped correctly. Maybe I should have done limited 5. Give it a moment. It's a bunch of data. It's a big files and maybe there are a lot of rows. As a shortcut, I could have, let's say, set paste, let's say, okay, how about, let's say, if I do Control C, see if it will stop it. Do Control Z. I'm also doing Control D to stop the process of scrolling. There's a shortcut I'll show you so that we don't take too much here. Okay, so if that is not going to stop it, then just run this on. Go back to Hue editor. Let me say close this one back here. Pardon me, sorry about that. Move this here back to web shell. Let's see if it will open another one. And we'll close this one. Say leave, back into shell, log back in. Say big, user 1. Password is one. Now we'll say, first one is you just type in hi. And what was the recent file? Commands. Okay, so just type in the first one as hi. Then you say show data basis. Say show tables. Say is what I'm going to be typing. You can type it along with me. Show data basis. It will give you a list of databases. These are all the different kinds of databases which have been built by other people. So we'll see if we can borrow one of the databases. Transaction sample DB. US selection. Okay. Let's see. Is it done? Okay. Zman, YouTube projects, YouTube analysis. Okay. We don't need the YouTube data analysis. Let's see if there is something, a built-in one here. Transaction sample DB. That is one thing I like here. Rest of them are trainings. Some people have built the Stack Overflow databases also. Let's say here is a sample underscore DB. Another one we may want to look at retail underscore test. Okay. NYSC. NYSC daily. Movie lens. Just looking for some interesting databases here, guys. I practice. I have sample DB. Sample underscore DB and I. So let's say we'll copy this one. I'll just put this here. Sample underscore DB. We'll also look at this. And let's say inventory insurance. Okay, we don't have to look at. Okay, JSON employees is another one. Okay, let's start with a few of these things and see if they can come to rescue. Use. Let's start with hype sample DB. I'll say show tables. Nothing. So then say use sample for DB. Say show tables. We have some new customers. Okay. Let's say select star from customers. We'll say limit 5. So this is like head of 5. So wife looks like they have some graph like data. That's not going to be very helpful. Customer underscore data. Customer underscore data. 5. Delhi and Chicago, not very useful there. Customer underscore Brownsville. Let's see how that looks like. Brownsville. Nothing. So we'll say use employees. Okay. Let's say use employees, and then we should say show tables. Sorry, show tables. Person 111. Say select start from person 111 limit 5 6 whatever it is, nothing is there. Back to use default is by default the default database, and now we'll say show tables. We'll see if we can pick up something from here. WC table, YouTube data analysis. We've already looked at. Okay, ideally what we show, that would have only a few columns. I'm looking for something which would have more columns than that. We can create it, but that I want to save it for the high part of it. Just for SQL part, I just want to see if I can run something. Transaction records will have only a few columns. I know that. Top rated. See what's on students. So select star from versus more time. Select star from students limit 5. Now they have some JSON data here. It's too early for me to explain you what is JSON data. Okay, I guess what we'll do is back here. I can load the data, but I'll need to run it in high. Okay. Pause it for a moment. May come back here. So we have any luck? Still working. Back here. One quick try. Sample. Okay, looks like we'll give one more try. So probably what I'll do is maybe I'll create a new database just for the SQL tomorrow, and let's optimize the time like that, guys. For today, we'll come back here, back to SQL, bring this up. One moment. Okay, guys, sorry about that. So let's say I was just looking for a way to execute these things in Hive directly. But what I'll do is I'll try to create a database maybe tomorrow, and I'll try to keep it ready so that we can save some time. We can try to execute these things and run there, guys. Okay. So what we'll do is we'll try to wrap up here for today. Any questions before we wrap up here, guys?
Sir,
Yeah.
share that PPT to the Lakshmi or in the drive, sir, so
Oh,
that
yeah.
we can go through that
Mhm.
once.
The Hadoop one you're asking?
Yeah, sir. Hadoop and SQL today, some part is gone, explained, right? That one.
SQL, I'm making a few changes. Once I make the changes, I will upload it. The Hadoop one, I will add it, Niharika.
Yes, sir. Already in the DNA, Lakshmi or Savitri, they are uploading it in the one PPT's folder. So that if you can share it to Lakshmi or Savitri, they will add it in that place.
Yeah, I think the same folder I also have access,
Yeah, sir. Okay.
the one that you have, but I have not checked it. But yeah, I can add it there, or I can add it in the TM drive also.
Okay, sir.
As I said, I'll add it for now in the TM drive, and later we'll pass it on to that one. Okay.
Okay.
Yeah. Thank you, Neha.
Thank you, sir.
So, guys, I want you to practice. I want every one of you to practice the Python and things like that. We'll continue our assessment tests and things like that in the coming up days, and I want you guys to be ready. And we'll be revisiting Python, some of the Python concepts as part of Hadoop and other things that we are going to be covering, guys. So be in touch with them and continue to practice them, and don't just stop practicing. The more you practice, the more it will be helpful, guys. Okay. So let's see, any questions before we wrap up today, guys? Demographic data, could you please explain this command? Hadoop FSCP is copying it from the first floor and pasting it in the first floor, Lavanya. If you use FSPert, you're getting it from the ground floor and putting it in your first floor, which is Hadoop layer. Whereas if you say CP, you already have a file in your Hadoop layer in some location. Let's say that is demographic data. You also want it in another location. You want it to be called as, let's say, demo2.csv. So it's going from first floor to first floor, from Hadoop to Hadoop. Are you understanding, Lavanya?
Are we creating demo 2 and copying the demographic data into it?
Okay, so let's say blanket. Let's say here are a couple of servers for sake of simplicity. You put a Hadoop layer here. That's the Hadoop layer. And let's say here is, choose this one. Ideally, imagine this as a file. When you do a put, you're copying it here. You're pasting it here. Let's say this is in directory D1. We'll say here's directory D1. You have done a put here. This is PUT. Okay. When you do a copy, what you're doing is you're taking this one, copying it from here, putting it into another directory. So let's say another directory or another location in the HDFS. And this is FSCP copy. What you're doing is choose this, you're pasting it here. Are you catching it, Lavanya?
Yes, no.
Going from here to here, the copy is going from here to here. Just from a different location to a different location. Visualize this is copying it and pasting it here.
Are we copying this file into the directory name room 2?
Yeah, that's right.
Okay.
You can,
Why are we written demo 2 here?
we are just giving a different name. If you want the same name, you'll just say room2_h. If you
We are
want
changing
your own
the name at the same time we are copy pasting the file, right?
Yeah, you're copying, you're pasting it. After you paste it, it is getting renamed to demo2.csv.
Okay, Naveen, thank you.
Okay, good one. Okay. So gentlemen, ladies, everybody practicing Python? Can you give me a quick yes? How many of you are practicing Python? Continue to practice Python, some of the Linux commands and things like that. They're all going to come your way for assessment. So please try to prepare yourselves, guys. Okay, that's for your own good. It will be helpful and useful for you.
When is our assessment, Naveen?
We'll tell you. We'll update you. Okay, buddy? Okay, guys, for today, I'll stop it here. Looks like I also need to step out. We'll continue the journey from tomorrow and go from here, guys. Everybody okay with that? Okay. Signing off for today. You guys stay safe and keep learning.
Naveen, can we have this test for 10 people?
Oh, okay. Okay. Shall we do it tomorrow, Lakshmi?
From tomorrow? All right. Fine.
Yeah, I just have something coming up.
All right.
So I need to address it. If it is okay, I'll take it tomorrow.
All right. We can do it.
Okay.
Yeah.
Thank you,
Let
Lakshmi.
me know the timing so we can do it. Yeah.
Yeah, same timings. We'll do it tomorrow, Lakshmi.
Sure. Thanks, Naveen. Thank you so
Thank
much.
you. Thanks.
Have a great evening.
Thank you. You too.